Leave. Thank you.
Okay. To start us off on an auspicious note, we will now have the virtual lamp lightning. With that now, I would like to request the Director of School of Arts and Science, Dr. R. Shanmugavalli, to please give the welcome remarks for the opening ceremony.
By the grace of Almighty, with the able guidance of Institute Management, I convey my morning greetings to the gathering present here today. My heartiest welcome to our Director Research, Dr. Satyamurthy sir. He is a noble person with a great scientific records, and we were pleased to have him to inaugurate this, our second national conference, which is on the theme of future perspective of basic sciences. We welcome you, sir, on behalf of all the science department and one and all present here. Wholeheartedly, we welcome you, sir. I welcome Professor Naharaj from NIT Warangal, who has extended his cooperation to present here for our inaugural program as well as for the forthcoming technical session. I welcome you, Professor Naharajan, sir. My great welcome and appreciation goes to Dr. Anandan, HOD of Mathematics, who is a pillar for organizing this National Conference on Basic Sciences. From 2019, he has taken a great effort. It was not able to possible because of this pandemic during 2020, but he was very sure to conduct this summer in the month of April for 2021. I welcome you and I appreciate you, Dr. Anandan, as well as all other HODs who have helped us to initiate this and conduct this national conference. Professor Basha, Dr. Kavita, Dr. Raghu, and all the science faculty members as well as students. I welcome you all. In this welcome note, I also would like to say this national conference is a scientific conference of SAS, where the first conference was held on 2019 in order to promote science and inculcating the spirit of science through this multifarious activities. The committee meets in first week of January for more systematic direction to the scientific inquiry, to promote interaction of students and faculty members, to obtain a more general attention to the objectives of pure and applied sciences. The association is formed with an objective to advance and promote the cause of basic sciences in School of Arts and Science, to hold an annual conference at SAS, to publish such proceeding journals and transactions and other publications, both by students as well as faculty members in considerable and desirable level. The association has steadfast work to uphold its objectives, taking science to the students. In forthcoming, because it was in pandemic situation, We have finalized to only to present the paper, but we had a plan of having a poster presentation as well as present a functional models by the students, and but that was not possible because of this pandemic. We are thinking of it, conducting it in 2022. We'll have all this poster presentation and model presentation, and some of the cutting edge technologies will be presented by both by the faculty as well as the students, and some scientific products and services and path breaking ideas in R&D and initiative will be presented in forthcoming 2022. Basic research is a key for planning and process of application, and therefore there is a need to promote and integrate basic research with the applied research. Mathematics is a curriculum should be reoriented in all level, keeping in mind about the advances in science and technology across the globe, as well as we want the School of Arts and Science, all the scientific programs, whether it is a UG or PG program, to uphold the mentality or the initiative of having research thought in their syllabi as well as in projects and for paper publications and in everything. That is why this national conference, with all hurdles and obstacles, we have put forth it, and we will uphold it in forthcoming year in a successful way, bringing in more industrial people to interact with us and support us for our forthcoming applied projects which we are going to come up with. So I wish this program every success, and I wish all my faculty and students to hold the spirit till their life period. And I welcome all my dear faculty members, my dear students. You hold the torch of science to enrich your life, because fundamentals of life relies on, or art of living is relies on the scientific mentality or scientific proceedings. So my dear faculty and all others, uphold your spirit of science in the School of Arts and Science. Once again, I welcome Dr. Satyamurthy, Dr. Professor Nagaraj, and all my beloved HODs and my dear faculty members and students. Welcome you all. Thank you.
Thank you, ma'am. I would like to request Dr. S.A. Satyamurthy, Director of Research, Vinayaga Missions Research Foundation, AVIT, to deliver the inaugural address.
Thank you, Dr. Saran.
Thank you, sir.
Respected Professor Dr. Nagarajan from NIT Varangal, respected Dr. R. Shanmugavalli, Director, School of Arts and Science, VMR of Deemed University, organizing committee members, HODs, my dear colleagues, delegates, very good morning to all of you. I'm very happy to participate in this second national conference on future perspective of basic sciences being conducted by the departments of mathematics, physics, chemistry, and computer science of School of Arts and Science AV campus. The topic is future perspective for basic sciences. When I heard this topic, I was wondering, what the topic is all about. Because for me, if you are living today, if you are leading a relatively comfortable life today, it is because of basic sciences. Tomorrow, if you want to have a comfortable life, basic sciences have to flourish. There is no other thought about it. So, there is nothing wrong in having such a conference and taking stock of where we stand in different fields of basic science, and start out a program for our own research things for the years to come. All of you know that the world is moving at a very fast pace as far as science and technology is concerned. Just to give few examples, maybe 50 years back, many have not seen a telephone. Today, the number of cell phones in the India, which is supposed to be a developing country or a slightly poor country, the number of cell phones is more than the Indian population. We are talking about 2G, 3G is over, 4G and 5G we are using. We are able to get connected from anywhere in the world to anywhere in the world. We are able to send messages, we are able to talk. This was not thought of few years back. Did you ever think about 20 years back that sitting in Painur, you will be able to book a train ticket from Bombay to Ahmedabad? It was not possible. When I came to Kalpakam way back, when I want to go to my hometown, I used to go to Central Station, stand in the queue for almost half a day for booking the ticket, and they used to give a small ticket which is 1.5 inch by 1 inch thing. Back of it, I used to write the seat number, etc. Same is true for medicine. All these things, many developments have taken place. Forget not that it is all because of basic sciences. Students, people, or parents may think the future of their children lies in engineering or medicine. I would say it's partly true, partly not true. I would rephrase the same statement that, to be precise, the future of engineering and future of medicine lies in basic sciences. Not the student future lies in engineering or medicine. The future of engineering and medicine lies in basic sciences and the way we develop. I'll give you a few examples to substantiate my point. The first microprocessor Intel 4004 was invented in 1971. That was a great achievement. People never thought that a small integrated circuit can do so much of functions. It has 2300 transistors. Today, the i7 microprocessor, which we are using in our laptop computers or desktop computers, has 3 billion transistors. That is 300 crore transistors. Intel i9, which was released last year, has 7 billion transistors. Your iPhone 12 mobile phone has about 12 billion transistors. How that was possible? It is all because of the developments in semiconductor physics. This, I would say, in spite of the fact that I belong to engineering background and more so for electronics and computer science, I would give the credit to semiconductor physics, material science for these developments. Today, our computers are having such a large processing power. It is all because of the developments that have taken place in this semiconductor physics. Earlier, people were talking about 100 micron, 10 micron, etc. That is the feature width or the transistors. Today, we are talking about 5 nanometers, 7 nanometers. That is still thinner than our higher width. That is the development that have taken place in photolithography technology. This is all because of physics and nothing else. Today, you go to any place, people talk about nanomaterials, how nanomaterials can be used for antimicrobial properties, various coatings, nanomedicine, directed drug delivery, etc., etc. In our campus itself, we have a nanotechnology lab, and many of our colleagues from School of Arts and Science are using that research lab extensively. Today, if we are able to talk sitting in different locations virtually and have a video meeting and having a talk on a very important topic, it is thanks to internet, which was started in 1970. For computers getting connected through a cable has transformed into internet. It came into India in the early 90s, and today we are using just like that. If you are in the office, you have a wide connection. Otherwise, you are on the road, you get connected through your mobile. We are able to get gigabits and gigabits of bandwidth. And in the house, we are most of us are having fiber connection, and it is able to transmit data at such a high pace, which was not the case a few years back. How this is possible? It is because of pure optics, pure optical physics, pure science, pure basic science. Everything which we are enjoying today, every comfort which we are enjoying today is because of physics. Coming to mathematics, there is no life without mathematics. Today, all strategic organizations are using cryptography, which is full of mathematics. It started with advanced encryption standards, then came RSA. Now we are using elliptical cryptography. People are afraid, and now all the strategic organizations, all the external affairs data or defense data is going through all encrypted mode from person to person or from country to country in this encrypted mode. People are afraid that once the quantum computers are going to come, which is not far off, already few prototypes are existing, all these cryptographic algorithms can be broken. And quantum computers is nothing but quantum physics. Again, it's a basic science. Coming to chemistry, we talk about polymer science. Polymers are used in our daily life. Whether we know or not, the Teflon coated pan or cookware which you use in the kitchen is based on a polymer. It is used in medicine for adhesive as an adhesive for implanting heart valves. Once you get up in the morning, toothbrush which you are using is based on the chemistry. Toothpaste which you are using is based on chemistry. The soap which you are using is based on chemistry. All the pharmaceutical industry today is based on chemistry, various chemical compounds, chemical formulations, etc. All these developments are taking place at a rate at which we couldn't think of earlier, and it's difficult to visualize how things are going to be in the years to come. Coming to computer science, it is a very fast changing field. Today we are talking about artificial intelligence, cyber security, data science. In fact, our campus itself is offering these courses. In fact, our School of Art and Science itself is offering some of these courses. If you look closely about the artificial intelligence or the cyber security or the data science, all the algorithms that are made which make it successful is purely mathematics. People may give fancy words, but the underlying thing is mathematics. Today, data science is one of the hot topics for any IT person. They get large amount of cost to company. It is all because of the development that are taking place in this area. Our university, our colleagues themselves are working in these areas, and AVIT is working in some fields like artificial intelligence in healthcare, especially for their early detection of diabetes, cancer, and neurological disorders. I can give examples like this, many examples. The future, I've not touched the strategic organizations like atomic energy or space or DRDO. If you look at, in fact, if you go and look into the systems there, the underlying thing is pure science. Today, if India is a nuclear power having certain number of nuclear bombs or nuclear weapons, it is pure physics. Engineers might have built the foundation stones are the basic sciences. The future of basic sciences is very much intact. In fact, the importance of basic sciences has increased over the years, and it is going to increase at a much faster pace in the years to come. I am very happy that School of Art and Science of our VMRF, under the able guidance of Dr. Shanmugavalli, has been doing a good research. They have been last year, when I closely follow, in spite of the pandemic, in spite of the many challenges that everybody faced, they had good number of publications. They had patents to their credit, and many credits to the School of Art and Science and faculty under the leadership of Director School of Art and Science. Very few arts and science colleges can boast of this. I'm not demeaning arts and science. As I mentioned for the last 10 minutes, what I was talking about, the basic sciences, which is taught in the arts and science only. Engineering is a different ball game altogether. Medicine is altogether a different ball game. I'm very happy that our School of Arts and Science has realized the importance of research, and I, as a director of research, I'm very happy about it. But there is a long way to go, and I am sure our Dr. Shanmughalli madam will take it forward, and it should be a role model. Our School of Arts and Science should be a role model for many colleges, not just School of Arts and Science alone, but even for the engineering colleges, etc. It should be a role model as far as research is concerned. Just to conclude, the way the developments are taking place, the oft repeated quote I will mention is that if you want to stay where you have to run much faster. That means you are at a certain development level, or you are going at certain pace of development. If you want to maintain the pace or increase the pace, you have to run much faster. That is how the world is moving. Earlier, few individuals or few organizations or few laboratories are working. Today, whole world is working. All the academics have got into the research. I do not know how all of us are academicians. I'm sure you would have gone through the new education policy. Just I will quote one statement which I keep telling to my colleagues, just quote and unquote, any university which is not carrying out research cannot be called itself as a university. I am repeating the statement, is quote and unquote, no extra words added. Any university which is not doing research cannot call itself to be a university. It's really true. I'm sure who have interactions with some of the foreign universities, most of the research output has come from the academic institutions and less from the research labs. Unfortunately, in our country, various factors are there, maybe because of the lack of realization on the policymakers, or maybe the lack of finances. Yes, we are a developing country. We started at some point of time when we got independence. But I would say, as a person who has seen, who has worked in a strategic organization, we have developed much faster when compared to many countries. In fact, I'm very proud to say that India has developed in some of the areas at a much faster pace than the developed countries. So now we have realized that the research has to be taken to nook and corner. Every college, every university, everybody has to do research. And once we contribute, I'm sure a day is not far off when we ourselves can call to be a very developed country on par with whether it is US or Germany or Japan or any other country. So, my dear colleagues, you are chosen a very apt topic of future perspective for basic sciences. I am sure in the coming 2 days you are going to have a fruitful discussions and stand on where decide on where we stand and what should be our future course of action for deciding where we intend to go. I am very happy and thankful to Dr. Nagarajan from NIT Warangal. Sir, I request you to visit our campus. I request you to give a more interactions with our School of Art and Science. I'm sure working in Institute of National Importance, you would agree that interactions help. Interactions help in bringing the peer competition, and we develop much faster rather than working in slows. Thank you very much for giving me the opportunity to share my thoughts. Thank you very much, and I wish the conference all success. Thank you.
Thank you, sir. And now, selected abstracts received in response to the call for papers of this conference have been edited and compiled in the form of conference proceedings. I would like to invite Dr. S.A. Satyamurthy, Director of Research, Director of School of Arts and Science, Dr. R. Shanmugavalli, guest speaker Dr. S. Nagaraj, and HOD of all department of SAS to join us for the release of conference proceedings.
ஹலோ கேக்குதா இல்லையா?
Thank you all. To introduce our guest speaker for the day, I invite Dr. S. Surendran, Department of Chemistry of SAS.
Yeah, thank you. Respected dignitaries and my dear faculty, students, and my dear participants, it's my immense pleasure to introduce our chief guest, Professor S. Nagarajan. Professor S. Nagarajan has completed his PhD in organic chemistry in the field of synthetic organic chemistry from Department of Chemistry, University of Madras, Chennai. And Professor S. Nagarajan was postdoctoral research associate in the University of New York, United States from February 2012 to January 2013 in the field of soft materials research lab. Then he have joined as a DST Inspire faculty on February 2013 in the Department of Chemistry, School of Chemical and Biotechnology, Shastra deemed university. At presently, Professor S. Nagarajan is working as an assistant professor in Department of Chemistry, National Institute of Technology, Warangal, Telangana. And Professor Nagarajan actively doing research in the field of synthetic organic chemistry, molecular self-assembly, gels, functional organic materials, carbohydrate chemistry, and sustainable chemistry. And he have published more than 57 research papers in various reputed international journals such as Progress in Polymer Science, Nature Scientific Reports, Journal of Biological Chemistry, Chemical Communications, Green Chemistry, ACS Applied Materials and Interfaces, ACS Sustainable Chemistry and Engineering, Journal of Material Chemistry, NanoSelect, Carbohydrate Research, etc. with cumulative impact factor of around 250, and 4 book chapters he have published in organic chemistry and materials. Professor S. Nagarajan has having Indian and international patents in his credit. He has received several international national recognition awards prizes, including NSF Postdoctoral Research Fellowship from USA, Inspire Faculty Award from DST India, Young Scientist Research Award from BRNS, Canara Bank Medal for securing first rank in MSc, excellent grade in DST Inspire Faculty Meet at 2017, etc. And Professor S. Nagarajan has selected as one of the members in Indian National Young Academy of Sciences in India for the period of 2021 to 2025. He has received several research projects from various funding agencies such as DST, SERB, BRNS, and MHRD. His research work was highlighted in the Hindu India Science Fair, Government of India, Malaya, Guardian, Telangana Today, and other scientific press. He has received several invited scientific lectures in the various national and international symposium, conferences, research courses and in other occasions. Thank you. Thank you for giving me an opportunity. Thank you, sir. Thank you once again.
Thank you, sir. With that, I will turn it over to Dr. S. Nagaraj to render the keynote speech.
Ma'am, am I audible?
Yes, sir.
Yeah. Yeah. Thank you, Dr. Surendran, for the introduction. And yeah, actually, like inaugural address given by Dr. Satyamurthy sir has like given glimpses on science and technology. Actually, he has like rightly said about like what is science and what is technology. And without science, there is no technology. That everyone should understand. And I like appreciate this Vinayaga Mission Research Foundation in many ways. One way is this organizing this conference. Especially like I see many conference and I give like lecture in so many conference. Either chemistry department used to like organize or physics used to organize. They organize separately. But here I would like I'm seeing that like all the mathematics, chemistry, and yeah, mathematics, physics, chemistry, and computer science all together like organizing a conference. This type of unity is very important to develop like a new product level or to perform product level research. Because as a chemist also I can just do some molecule and I can study and then publish. But this type of like multidisciplinary research, especially in the basic level, would really help, surely will help in developing new products. And yeah, so yeah, thank you, sir. Thank you, Satyamurthy, sir. Surely, like whenever I get chance, I will visit Vinayaka Mission Research Foundation, and it is on the way to my native place. Surely, I will visit, and like I will share my slide. Sir, madam, how much time, madam, for me?
Yeah, you can take your own time, sir.
Okay.
You can take your own time.
Yeah, yes. Slide is visible, ma'am?
Yeah, it will be visible, sir. Yeah.
Okay. Yeah, thank you very much. So today I will be discussing green and renewable resource in this guest address. So first, slides are moving.
Yeah.
Yes. So first I will tell some glimpse about our institute and then department. So we are NIT Warangal is top 3 among NITs and is in competitive with many of the IITs in overall performance. And we are having in our institute we are having MSc Organic and Analytical Chemistry, 30 student strength in each branch, and our admission is through joint, that is a central entrance exam, and we are having PhD chemistry also. Eligibility for PhD chemistry is GATE, CSER, UGC, JRF net, and yearly 2 sessions we are doing call for. And this 2021 onwards we are planning to start, because as you know, right, this basic science is very important for the growth of science, the growth of the country. Keeping in that particular view, not only like our institute, many institutes started and they are starting this basic science. So we are also starting from 2021 onwards, we are also starting BSc program in science, actually, especially science. So as you, because you are the leader, leading, you are what we say, the role model for us, maybe in this aspect. So we are going to start BSc in science, not in chemistry. So this science means equal. Hello, am I audible?
Yes, sir.
Yes.
Yeah, sir, you can proceed.
So
sir.
we are going to start a BSc in science by giving equal weightage to the maths, physics, and chemistry, and equally to the administrative MBA kind of management subjects also. There will be some little influence would be there from the engineering side also. So this is what our plan. 2021 onwards we are starting. Okay, so we'll directly go to the topic. So I just tell something about education and science. Education is that, in Tamil, I say, if other state participants are there, please excuse me. Okay, for this slide. This is the only slide I am having it in the Tamil. Okay, karka kasadara karpavai katrapin nirka adarku taka. So this is very important Tirukural. So it tells about education. So why we have to get education, why we have to get educated. So education means not just to go for job, it is a matter of leading life, how good we can lead life, that is based on the education. And science is not just developed, it is from ancient period onwards, has been developed. And recently a prime minister also, during his last visit, he told this particular, but I don't know whether he knows this real meaning or not, but the real meaning you might be knowing. So many comments also came. So this was okay, so I just read this. So that Varapuyara Neer Uyarum, Neer Uyara Nel Uyarum, Nel Uyara Kudi Uyarum, Kudi Uyara Kol Uyarum, Kol Uyara Kon Uyarvan. So Varapuyara Neer Uyarum. Here, this Varapuyara Neer Uyarum is the science. So if we make a kind of if we make a kind of what we say, a kind of barricade kind of thing, then water would stay in the land, and the same water is staying, not more water, it is required water. Required water is staying the same way. Nil, that is paddy, also would grow very well, and if paddy is growing very well, then obviously the country would grow. That means it is agricultural field, agricultural sector is the first. Okay, first and prior one, and that science, agricultural science is very important. That is what this particular poem is saying. And already this no arivu attram kakkum karuvi, that is what Thiruvalluvar saying. And arivin nutpamana malarchiye ariviyalagum. So scientific research is very important, and science is there in all literature. So we are not going to do, we are not doing anything more than that what our ancestors did. They did like excellent science, and maybe because of lack of documentation, all this, we could not like carry forward to the current generation. Maybe this is the right time to just relook into the ancient science and then find the scientific temper in it and proceed further. So here there are two types, because why I have selected these topics is so there is science in ancient history. So ancient history never, because though we are saying so many technologies as like Professor Satyamurthy said, like mobile phones, all those things, we are enjoying the technology, but our ancient science, ancient history, we see they didn't use any of the non-renewable energy. So they used only renewable energy to fulfill their needs. That is what very important point that we have to look. So for example, they used solar energy, they used hydropower energy, and they used biomass, geothermal energy, wind energy. All this renewable energy they have used for their day-to-day life, and to develop, for the development of the society, for the use of the society. And nowadays, because of maybe so many reasons, either the population reason or like economic reason, so many reasons, now we are going for the fossil fuels, coals, nuclear, natural gas, all those things, depending upon the requirement, because this is purely depending upon the requirement only we are going. But when we are going to the non-renewable resource, obviously they end up with a lot of problems. One such example I would like to say, when I was kid, to buy like rice in the shop. So I used to carry like a cloth bag. Like they used to stitch, very well, and there is some hole, no? So like that a shop guy used to like make small paper in the cloth in that hole, and then just he pour rice. So then like when I'm bringing, that paper used to move, and then sometimes it used to like spill out. So that, because that time I was like I got frustrated. After some time, what happened then, polythene bag came. So I was very happy. So you see how good the technology developed, and you see this cloth bag has been replaced. And though cloth bag having lot of problems, so that particular handle would do that handle, that would like get tarred, so that problem there, and may have like a hole. So but when we go for polymer, there is no hole. It carries lot of weight. So like that I was very happy. So what like great invention. So when I was kid, I was impressed, and then I myself realized that okay, really science is great. And from that time I thought like I should go only science. Okay, so next now you see the whatever the thing that I have realized 20 years back, very good. Now I am realizing that that is not good, and I am thinking that we have to go for the cloth bag. And in our institute also they have given like couple of cloth bag. When we are going for purchase, we have to use only cloth bag. That is what the instruction given. So instruction given and cloth bag also they have provided. So that particular like what we say, that scientific relook is there, because we have like we thought that polythene bag is good, but now it is bad because it is causing pollution. The same way, the problem is when we invent something, we always look on its beneficial side, its positive side, but we won't think about the future perspective. So here it is rightly said that future perspective of basic science. So how we can use the basic science for the development of society. So that is very interesting topic. And since these maths, physics, chemistry, and computer science are there, so all together discussion all together would really bring product level outcome. That is what I believe. Okay, so and another slide, this is very important slide that I want to discuss. Okay, so you see here in this, just a minute. So pointer is visible?
Yes, sir.
Yes, thank you. So you see here, this is the crude oil. When we go for shopping, especially for shopping, whether like villager or someone from village or someone from city, For washing, what we take washing powder. And for like we take Snickers, we take like crunch berries, we take like various food items, especially various food items. If it is summer, we take cool drinks, soft drinks, and then we take like oil. So all we take from the shop. You see here, many of the products given over here were either directly derived from the crude oil. Okay, this is crude oil. Okay, either directly derived from the crude oil, or like they use crude oil product for in one of their steps, one of their process steps. Okay, so that is what I want to tell. So whether we are really taking food, we are really taking or utilizing our resource, or we are taking something like which is the fraction of crude oil. So crude oil, anyway, we need it for like we have to use it like one of the fractions, we have to use it as like petrol, diesel, and some other applications. But there is like lot of waste. So what they thought, like, okay, this waste from the crude oil should be made as valuable material or valuable molecule, so that can be utilized in the various products, like either cosmetics or food products. So we are directly or indirectly taking this crude oil. So that is not good for the health. That's why, like, you see nowadays, no, there is like heart attack coming, there is like BP coming, sugar coming, lot of problems are there, because this type of problem was not there earlier. And one such example I want to tell. Okay, so you may think that 1 kg of for example groundnut, that is peanut, okay, is cost rupees like peanut is 200 to 300, 1 kg completely dried. Okay, but you see one liter of oil that shop guy is selling for 150 rupees. Am I audible?
Yes, sir.
Yes, okay. You see, 1 kg of peanut or like groundnut is 200 rupees on average, we say. Coconut is 300 to 500, but we take groundnut as example. So, if we take that groundnut oil from the shop, he used to sell for 150 rupees. In bulk, how much he will get? He will get 100 rupees. 1 kg of oil, from 1 kg of seed, if we take oil, it may like to the maximum we may get 400 ml. So on 400 ml we will get. So for 200 rupees he is purchasing that groundnut seed, and then he is doing process so many things, extracting oil and packing everything. After that he is selling for 100 in bulk, and the shop guy is giving for 150, because he also keeps some profit. No, how come that 200, after investing like after taking 1 kg, doing several process, the price of that oil, that is the groundnut oil, should be around 400 to 500 rupees. But how come that shop guy is selling for 150? So do you really like think like whether it is oil or it is something else? So if we think that way, it is not pure oil. So they just take the mineral oil, light paraffin oil, mineral oil from the or we say the waste from the crude oil, and then mixing with some flavor and selling in the name of oil. So if we take this type of oil, it really causes the health problem. So this type of education who will give? So we science we like the science department should provide, should make such awareness to the students, not just like teaching organic chemistry and physical chemistry, or in physics basic principle we have to tell, but we have to tell about the real situation, like what it is and what is happening, everything that we have to tell. So what I suggest is, before taking like any product, first all the students, because this education used to give this knowledge, okay, analysis knowledge. Normal common man without having education cannot. So that's why like every time they stress education is very important, and the educated society used to develop like that. They used to keep on telling that education means not just I just take couple of courses, I complete with 80 percentage, and then like get a degree. No, it is not that way. So education will seed analysis skill on a person. So that is what education is. So after once you educated, you have to analyze, not only in one way, like product, you have to analyze in all the ways, so that because you are living in the society, that is your society, you have to make your society very like very good, like very livable or like say lovely, excellent atmosphere, so that you can live very conveniently, because you are not alone, you are not separated, you are not in some other place. So you are there in the society, society is part of you. So society is happy, you will be happy. So that you please remember, like all the participants. Okay, so here I say critical thinking of societal needs, because what we are doing, whatever the research is. So Vinayaga Mission Research Foundation has like started doing good research, and since they got like autonomy, they can even perform very well than the some of the very like some of the what we say the national importance institute of national importance, like IITs and NITs, because they are in this type of institution. Like private institutions or like public aided institutions are having like autonomy, complete freedom. Whatever they can do, they can do. Whatever they want to implement, they can implement, no problem. So tomorrow some facility needed, no, they can make it, arrange it in the next day itself. There is no one to stop. But these public institutions are not like that. So they got lot of advantages. And then I wish I wish Vinayaga Mission Research Foundation should come up with flying colors in the research and come up with a lot of products. So because nowadays we need product level research, and that product also should have the green sustainable touch, so that it should not harm the society. So many things that we have to think about the society, whether it is harming society or not. That's why first points I put like critical thinking on societal needs. So next one is problem solving. So problem solving, who will solve the problem? Obviously science. Without science, who else will solve? So for example, one example I will tell. Okay, there is like in blood vessel, there is small fat deposit. Okay, small fat deposit there in the blood vessel. So the flow of blood before the fat deposit and after the fat deposit, who will calculate? Engineer can calculate? No. So only science can calculate, especially mathematics can calculate using the mathematical equation. So this is where the science comes. So problem only science can solve. Without science, there is no engineering, nothing, because engineering can give jobs. Okay, but it cannot improve life. There are two things. One is life, another one is aiding life. Now you see the COVID pandemic came and the coronavirus. They immediately went to the engineer to solve the problem? No, right? They came to the science. So what is the first, you have to find out what is the structure, what is the like it is made up of what type of molecule, what is there. So whether which drug molecule will go and interact. So they came to the science to like ask help. So they asked help from science and then medicine. So medicine also comes from science. It is not like separate topic. So organic chemist should make the molecule, so that came as even paracetamol is the organic molecule. So not only I'm saying like so computer science, all basic science program are very, very important, and that used to solve the societal problem, and that will give the solution, and from the solution maybe engineers can develop a device or technology, and that can benefit to the society. Because when you see the society view, okay, society is seeing, okay, who is giving the product. First, who will be there? Engineers will be there. This engineer is giving the product, like that. So that kind of illusion. So that particular thing has like appeared in the society, and they were thinking that okay, engineering is very, very important, and we are getting because of no, science is behind each and every engineering development, and without science there is no development. So that's why currently not like India now in India. They have like realized the science, and now for science research, government has allotted little more funding. Last year it was pathetic. Now government has allotted very little more. Okay, comparatively good amount of funding for the scientific research. And some developed countries, you see, like USA and Japan, you see they like spend a lot of funding for the scientific research, like especially science. So engineering used to be like private sector, and science used to be in the government sector, so that science development they can take care. But here it is in the reverse way. Anyway, slowly the situation will change, and we'll go to the topic immediately. And like yes, so new education policy and all those things Professor Satyamurthy sir was telling. And here I want to tell, just a minute. Okay, here I want to tell, like, there is a gamma ray, X-ray, UV, visible, infrared, microwave, radio wave. Who invented all these things? So all these things are coming in the science, right? It is not like in the engineering. So they may use the extract of this, and E is equal to h nu is equal to c by lambda, and nu is the frequency and lambda is the wavelength. So frequency is directly proportional to the energy and wavelength is inversely proportional. You see here this particular just a minute. So pointer is visible. Yes,
Yes, sir. Yeah.
yes, you see here. Okay, so if you see here, what I told, frequency is directly proportional to the energy and wavelength is the inversely proportional to the energy. So you see gamma rays, this is like high energy radiation, one cannot tolerate. And if you see like this side, it is the radio wave. Okay, one can tolerate. So using the radio wave, we are sending the signal and taking the signal. We are enjoying the facility of mobile phones. All you see, like Satyamurthy sir was telling, like the number of mobile phones in India is more than the number of like populations. So that means that importance that we are not importance that we are enjoying the application of this particular basic concept. So who developed all these concepts? Only science. So science is very, very important, and I appreciate all the students who are participating in this conference. So you have taken a very excellent decision. If you know science, you can develop new product, and you can try your own like a small product. And now government also like supporting some startups. If you have idea and if you have product level preliminary result, okay, then you can approach the government, and government used to give like some basic funding so that you can make your product and then sell nearby. And the early turnover, if you give, they used to give little more funding. So that funding also like is free of cost. So the only thing is you have to give the concept idea and then like some model. So that model is needed. So there are a lot of opportunity there. So science students, don't lose your hope. With your scientific knowledge, you can develop some new technology and new device, and you can be an entrepreneur. So what I'm saying is, for all the development, so you see, so all the device, for the behind all the device there is a science. So such science is very, very important. And now so as a chemist, I am going to my own topic. So there are 12 principles of green chemistry. Since I am organic chemist, I used to like make green chemistry. So as I told in the second or third slide, our end, if we look on our history, they didn't use any of the non-renewable resources. So they used only renewable resources for their life. So I request you, okay, all to follow the same. Don't get deviated. So to the maximum extent, take product, renewable resource based product. Okay, you can make it or you can buy it, but please use the renewable resource based. And when you are doing also, please do it so that, because this is our environment, we have to leave good environment for our next generation. Please keep that in your mind. We can enjoy the facility. Okay, please my humble request is, we can enjoy the facility, our generation, I can enjoy all the facility. Okay, but we have to think about our future generation. If I enjoy and I throw all the garbage and the environment, how come our future future generation will enjoy? They will be on garbage. So throughout their life, they have to wear mask. Throughout their life, they cannot like go by walk. Throughout their life, they have to like keep their oxygen cylinder on their bag, like backpack. So we have to do this way. We have to do this way research, or we have to develop such product. No, not needed. So we have to keep that in your mind. Use renewable resource as much as possible, and then like give good environment for the future generation. So already I told, it is prevention is better than cure. So what I say, don't make anything non-renewable one. So it is better to prevent in the beginning itself. Use only renewable resource to develop any new product, and even the cost, maybe economy wise, so many things would be there, but it is your job to convince. And now the society also ready to take. For example, one product, non-renewable product is cost 20 rupees, and one renewable product of cost 30 rupees. society is ready to take, because now all got educated and they know about the pollution, and so they are ready to take. Even the cost is like 40%, 30 to 40% more also they are ready to take. And next one is the atom economy. Atom economy, where it comes is we have to use atom economy. Generally it goes to the atomic level, but generally I say whatever the material we give input, so almost 90 to 95% we have to take it as output. For example, in a molecule, like in a transformation, like an organic transformation, if you use like a molecule of total atom of 30, in the product at least 28 should come. 30, all the 30 coming is good, but at least 28 should come, remaining 2 may go waste. So it is just molecular level. From the molecular level, from the atomic level to the maximum material level, we have to minimize the waste. We have to waste or maximize the atom economy. That is what the second principle is. And third principle is less hazardous synthesis. This is very very important, and now we are using like nuclear power plant, all those things. So now government also giving lot of subsidy for solar panel, and the solar panel is simply made up of silica is nothing but sand, so there won't be not much problem. So what I say, go for less hazardous fabrication, less hazardous protocols. Okay, in organic synthesis, less hazardous synthesis, so use water, use room temperature reaction. You see plant, whether it is using like 200 degrees Celsius to produce the carbohydrates from the minerals, water and carbon dioxide. No, right? It is using room temperature. So why we have to go for the higher temperature? So go for the lower temperature. Less hazardous synthesis should be adopted to get the product, maybe someone organic. And non-organic also, please use less hazardous method, less hazardous product. Develop less hazardous product. Don't use like something like even this mobile phone. I am very much like afraid. Now we in mobile phone, no, like Sat told, our number of mobile phone is more than the population. So after like use, because every year or 2 year, after 2 year, mobile phone used to like dead. So we just throw. So the mobile phone is the lithium ion used in the battery. So where we just dispose, it is the lying like in the down the earth. We are taking it and then using it. So once lithium is getting exposed to the society, if we take lithium mixed water, what will happen we don't know, because we are having like sodium potassium pump in our body. Once lithium get into our body, whether it is going to affect the sodium potassium pump, I am very much afraid, because not such research were going on, and they are not thinking about the future. And then just like now lithium battery coming, and luckily someone started developing the sodium battery, but its performance is not up to the mark. So but still it is going on luckily. But lithium ion battery, I am very much afraid, because we are having very very important sodium potassium pump in our body, and lithium is going there. And similar monovalent ion, whether it will like make any harm there, surely it will make. There is no other, because these biological systems are very very unique. Size or shape or charge, it is very very unique, and the different size, shape coming and charge coming, obviously it will get collapse. And when we were making a molecule, or when we were constructing, we have to use safer chemical. That's why I say renewable based molecules can be used for the synthesis of polymers. For example, lactic acid you can take and make a polylactic acid. So polylactic acid coating can be given on the tablet. Lot of applications there, and lot of limitations also there. But we have to use safer chemicals, especially the renewable chemicals for our research. So next one is safer solvent. Especially this safer solvent is for organic synthesis. What I suggest is maximum use water as a solvent. Water is very good solvent, and using water is, without water also very good, but use water as a solvent for the organic transformations or for any synthesis, even nanomaterial synthesis or any synthesis. We have to use safer solvent like water, or you can take some renewable solvent which is obtained from the renewable resource. For example, after taking sugar, and that particular sugar bagasse it is called, so that is on fermentation gives ethanol, so that ethanol can be used as a solvent. So because that is obtained, so renewable solvent can be used for the synthesis. especially non-toxic. It should not be toxic. We should not use toxic solvents. For example, benzene we should not use. So these are all some of the principles. So there are 12 principles, but what all the 12 principles says is follow whatever the science developed by our youngsters. That is what it says. Okay, keep your environment clean. So keep like a good environment for our future, for our kids. So like that, that is what the principle is. Maybe several points they have made. Energy efficiency already I told. Okay, we have to use like energy when you are going, like it is already instructed. Okay, in our institute, all everywhere, if you leave the room, switch off the fan and light, like that. So energy efficiency is very much important, because first law of thermodynamics, energy can neither be created nor be destroyed. Universe as a universe, so whatever the total energy, okay, whatever the total energy is zero. Okay, so you should not like if you use one way, like if you use energy in one way, so it is like taken from some other source. Okay, so that is converted. So as a universe there is zero, the total energy change is zero, but you are taking from one, so there is a process. Okay, so to process again there is some energy needed. So all these concepts should be kept in mind. Okay, and for synthesis, for example, 1 gram it is fine. For 1 kg of cooking rice, you have to provide some energy. For example, if you like cook tons, several tons, you need more energy. So energy is very very, in small level you may think very little, but when you go for the bulk production, it is like more. So we have to be like very much careful about the energy, okay, usage of energy. So what I say, room temperature reactions can be performed. You should not go to the higher temperature. Especially you can use like solar light for certain transformations, organic transformations. So that these are all the way like to save the energy. And renewable feedstock already told, and then through in my presentation I will be using the renewable feedstock. How one can use the renewable feedstock. Okay, reduce the derivative, that is very important I told. So for example, A gives B plus C plus D product. So we have to think about what like what C is needed. A gives C, B, C, D. C is needed, but B and D are unwanted. So we have to reduce the unwanted material production. So that was lacking in the industry. Please understand that is lacking in the industry. So they just take the desired one and just throw all the garbage into the either nearby lake or pond, thereby lake, pond, and all the atmosphere getting polluted. And because of the poor monitoring, that is also very important. It's very rightly, it is like right time to specify poor monitoring, where the like arts department what I say, can look on it. Okay, so poor monitoring is, for example, one industry is producing lot of waste. As per rules, what they have to do, they have to process the particular material thing and then release the pure water, and then take all the garbage and safely dispose. That is the rule. For with that particular thing only license has been license, the government used to give license. But because of the poor monitoring, what they do, to process this they have to spend lot of money than the production. So what they do, they will just produce, and whatever the waste water is coming now along with the waste, they just discard. And especially the inside they put like tall walls. Okay, and then inside they will just pour, and that used to go to the soil, penetrate into the soil, and then that percolate into the soil along with the waste. Sometimes organic material used to get decomposed, or it won't, some polyaromatic hydrocarbons won't get decomposed, that will get into the water, and that cause cancer. You see the small kid, okay, 1 year 2 year kids are getting cancer, whether they smoked, they took alcohol, they took any kind of like packed food item, no, right? So maybe they may be taking water or something. So we have to keep our society very very clean and thinking about the society, because society is very important. And the product which we make also very very important, and it should be beneficial to the society by keeping the green aspects. And catalysis we should not use, especially, okay, in our body so many, okay, enzymes, we are having enzymes are nothing but proteins performing certain tasks. This is simple definition for enzyme. So enzymes, these type of enzymes are performing brilliant, excellent task where one organic, even if you spend several billion US dollar, such reactions are such kind of catalytic reactions cannot be mimicked. So such excellent biocatalysts are there. One should use such excellent biocatalysts to the maximum extent for the transformations. If not, you can use like normal catalyst, but don't go for the metal based catalyst. It is a problem. And we have to design product in such a way that that should undergo degradation. Okay, maybe within short span of time. Real-time pollution should be prevented and accident also should be prevented. These are all the 12 principles, green chemistry principles. I will give a couple of one such example. So here you see this first, this is the one chemical process. In chemical process, we have to use raw material. How raw material should be? It should be renewable feedstock. So we have to take it from the renewable feedstock. Like renewable means within short span of time we can regenerate. Non-renewable means we cannot regenerate in short span of time. Again, that is having lot of problems. So don't go for the renewable, non-renewable. Go for the renewable and then select it. And after that, what I say is use less energy for this particular, because this is the starting material and this is the product level. Okay, this is the product. So here in between we have to use certain catalyst. So what I suggest, use biocatalyst, that is best one. If biocatalyst is not available, use like environmentally friendly catalyst or catalyst which can like use very like catalytic amount, not the equivalent amount. So very less catalyst, that means catalyst, whatever the metal we are using now, that should come into the next cycle. So no need to like keep on adding in the equivalent amount. Maybe catalytic amount is enough. Such catalyst can be taken for organic transformations or any kind of conversion. Use less energy. That means don't use high temperature. Room temperature is important. Minimize number of steps. So this is also, if you make like more number of steps, obviously the cost of the product also would be more, and same time there will be lot of side product producing that will pollute the environment. So use like minimum number of steps, and product also we have to get the desired product, not the unwanted product. We have to frame a protocol. So if one keep all these concepts in their mind and frame a protocol, research protocol, then surely you will come up with very good product, and that would be to the maximum extent would be beneficial for the society. So it will go to the product level also. So that is what I want to tell. So such I will give, this is general chemical process, how one can make it as a green and sustainable way. And this is the another method. Okay, another method is a specific example. So in the year 2002, okay, this company, okay, this is a Cargill Inc. and Dow Chemical. Dow Chemical, many might be knowing, like, right? So these two, Cargill Inc. and this Dow Chemical, got the award, that is a Presidential Green Chemistry Award from US, from the president. This is very prestigious award given to the industry which is like contributing more towards the society. So what they did, they developed one bio-based plastic resin. Okay, to make plastic, they made resin. That is what their thing is. So what they did, they have like produced, okay, this bio-based plastic resin from renewable resource, that is corn. You see this corn is there, no? They used this corn. And what their achievement is, they have reduced the consumption of fossil fuel by 30 to 50%. Earlier, we all use only completely fossil fuel, that is non-renewable resource. But they here using this particular method, they have reduced to 30 to 50%. 50%, that is great achievement. So after this particular, what they did, they took, this is a corn starch, that is corn material. They did the fermentation, and then they made polymerization, and they got the resin. You see here, this is the company website, and then you see here from this resin, one can make n number of product. That is, one can make t-shirt, cups, pipes, container, all plastic material can be like made from this. So that's why this particular award has been given. Okay, so here what they did, use the renewable feedstock, that is corn. They use very less energy because no need of heating. They used fermentation. Okay, fermentation is very simple. How you will convert milk into curd? Just you add like a little curd to the milk and the entire milk used to convert it. Like that, fermentation is the process, simple process, no need of any type of energy. And they use this biocatalyst for this particular transformation. Okay, and within like few steps they made the product. So this is what the achievement they made, that those company made, and they got the presidential award. Okay, so why we need the renewable resource? I think I will finish in maybe 8 minutes. Okay, so renewable resource, why we need it, is globally accessible, biodegradable, and then depletion in petrochemical based resource can be avoided, because it is always carcinogenic. You know very well, most of the material are carcinogenic, and especially these renewable resources are inexpensive because we are getting it from nature free of cost. Some of the example for this renewable resources like carbohydrates. We are eating no food, rice, carbohydrates, nucleic acid, which is in our body and all the living organism, amino acids, peptides, lipids, vegetable oil, and lignin, so many things. So we have written like one review article on this. It has been published in the like polymer chemistry journal. So if someone want to see those renewable resource based, how one can one can play with renewable resource to make the product, you please see that review article. And here you can use any of the renewable raw material to make product. So that is what the idea is, and towards this particular goal only we were working, our research group is working. And another important thing is because many were not realizing. So yeah, during your students, dear students, during your maybe like higher secondary, you might have studied the periodic table. And in human body, not even in human body, in life, entire life, you see universe just see globally, entire life, only 25 elements are essential. Among 25, 4 elements make up to 96%. You see, 4 elements, what are they? They are carbon, hydrogen, oxygen, nitrogen. So 4 elements makes 96%, means when we develop some product, we have to use only these. Okay, product means a product for life. Okay, please listen. There are two points I told. One is life, another one is aiding life. Okay, so aiding life means that may like make our life simple means that will helpful. So for example, you are doing like you are like what we say, so you are it will help in like lead our life in a easy way. For example, you manually do certain task, no, so with the help of aiding life technology, you can like reduce that particular process. Manual process can be replaced with the machine based process. Okay, so what I am saying, for life, if you want to make any drug molecule, so if you want to make like any kind of cosmetics, if you want to make like what we say, soap, paste, or any kind of life pharmaceutical product, any life related product, please use only carbon, hydrogen, oxygen, nitrogen to the maximum extent. Some little amount of phosphorus, calcium, sulfur, potassium also can be there, but it should be very less. So make use of this carbon, hydrogen, oxygen, nitrogen. So to the maximum extent to develop a product which is helpful for the life. So for our research also we use this carbon, hydrogen, nitrogen, oxygen. That's why I am in organic chemistry. Otherwise I might have like moved to because after getting this knowledge only I just joined the organic chemistry. So otherwise I might have gone, because my interest is in organic chemistry. So we have selected these elements for our research. And so in our lab we do self assembly. Self assembly means it is very simple. You take one brick, Okay, using that brick, one can construct n number of architectures, like one can construct tall towers, railway station, educational institution, okay, bus stands, okay, then house, so many constructions. So all these are all performing different tasks. Okay, that is very important. So we are using only brick to make various architecture, and this architecture perform various tasks. Similar to this, in living system also, these molecules are there, either amphiphilic molecules or we say polymeric molecules. That self-assemble gives you the supramolecular architecture. So that perform various tasks. Thereby, all the living things, planets, cosmos, in everywhere there is a self-assembly. So you see, I will tell one small example. You know, like cell wall is there, cell wall. So cell wall rupture happens means cell will die. So cell wall is made up of simply molecular self-assembly by means of phospholipids. You see how brilliant this what we say this nature is. And one cell is used to communicate with other cell by means of this is glycolipid. Okay, so this glycolipid is helpful to communicate. One cell is communicating to the another cell. You see how brilliant the science is. It is not technology, it is science. Okay, how brilliant the science is, and that science, how it is making the living things, planets, cosmos. You realize we all should be like very much proud. Okay, when we say like I am from science team, so I am the one responsible for like responsible for all the development, like that proudly one should say. Okay, using this we can get various number of architecture like micelle, inverted micelle, and then fibular structure, helical structure. So many things are there in the natural material, living things, and which involves various interactions, where all especially physics, chemistry, and mathematics also used to like calculate the interactions, yeah, how much energy, all those things. Okay, computer science also use this particular concept. So all together science, various interactions are used, like ionic interaction like NaCl, hydrogen bonding, pi interaction, van der Waals forces, CH pi interaction, anionic pi interaction, cationic pi interaction. So many interactions are there. Okay, so using this interaction, it used to self-assemble and give a lot of self-assembled material and performing brilliant tasks. So there are different assembly process. I will just tell these basics and like finish. Just maybe I will take 5 more minutes. So there are two types of assembly process. One is static assembly, another one is dynamic assembly. Generally, static assembly is kind of folding of protein molecule in bio. Someone is there in biology, and the chemistry students also can understand. Biology also can understand. Physics also to some extent they can understand. Computer science little hard, but your contribution also can be made in this type of sector. Okay, don't think that only like I will write some program for performing like bank transactions. No, it is not like that. Okay, you also can develop a right program for MRI scanning. So many lot of scope is there. Okay, so there is static assembly. Static assembly is the protein folding example, and dynamic assembly is there. No, it is the spooling. Okay, solar system, galaxies, cooling of fish in water, all those things. We took a static assembly process. So in static assembly also there are two types of assembly. One is instructed assembly and another one is self-assembly. You see here, this is a self-assembly. This is amphiphilic molecule. Red dot is there. No, this red dot is a head group and this is tail group, like soap you are having. That is one example for a surfactant that used to self-assemble to give that bubble, that soap action. Okay, so no need of energy. So automatically will self-assemble. Instructed assembly is through chemical reactions or through enzyme reactions or through ligand receptor interactions, it used to happen. So like GDP to GTP, okay, diphosphate to triphosphate conversion, okay, tubulin molecule formation. So all these are all the examples. So natural example also there. Using this particular process only, we have like developed a lot of things. And in our lab, we use gel molecule. You see gel is there. For example, ointment you apply, that is nothing but gel. In biochemistry, they use gel electrophoresis. There also gel, aloe vera gel. There hand sanitizer also nowadays. No, so you sanitize your hand. That is also nothing but gel material. Okay, it is there everywhere. Self-assembled material also there. Gel also there. Okay, so with this particular concept, we have developed a lot of material that is for self-assembled material for drug delivery application, surfactant material science, bioimaging, antimicrobial agents. So many applications we have realized. And design parameters, generally there is no such design parameters given in the literature till to date. Okay, you have to do it trial and error basis. One important thing that you can keep in your mind is you can try to maintain the hydrophilic lipophilic balance. This concept may be little bit helpful in designing the surfactant molecule which can undergo self-assembly to give the supramolecular architecture, and that can perform brilliant task, because natural cannot provide a lot of things. When you can go for the value added material, natural material cannot fulfill the requirement of the, let me say, the society, okay, or people. So we have to go for the synthesis. For synthesis also, what I suggest is you go for the renewable materials and synthesize such like a brilliant molecule, either drug molecule, and in our case we have made like amphiphilic molecule by using simple synthesis starting from the renewable resource, which mimics structural, functional, aesthetic and biological aspect of the natural surfactant molecule. So this way we have made. And here what in this case, no, biofilm formation is very big issue, like urinary tract infection. So many problems are because of the biofilm formation. For that we have found, okay, we have made a molecule. Okay, here you see we have made a molecule. In this molecule, this is sugar molecule and this is the cardinal, that is cashew nut cell liquid. We have synthesized this molecule and this has been used for like eradicating this. More green is there, no, more green means biofilm formation there. You see, after treatment with our molecule, there is no green. Okay, so what this suggests, this particular molecule can be used for clinicians to wash their hand and to eradicate biofilm formation. This has came in like newspaper, Hindu newspaper, and got wide publicity. And we made based on the ancient history. Okay, so the door handle they made with the brass, no, like copper zinc alloy. With that particular concept, we have made a kind of coating material. This coating, non-leachable coating, okay, can be used for coating in railway stations, because where more infection patient can come and touch their hand on walls, the other person also going and touching, no, then what will happen? He will get the infection. For example, here I will tell. So some maybe elders know, they go to the hospital themselves, but kids know what they do. If they get cold or fever, parents should take. So once we go to the hospital, kids kid infection used to get recovered, but immediately after parents used to get the infection, okay, like cold or cough or fever, whatever the thing is. So because the particular surface, no, that infection bacteria used to go once you touch, and then some without washing hand, if you eat, that used to get like give infection. So in order to avoid those infections, we have made a kind of coating material, and we coated with urinary catheters. Here you see more pathogens here, and here it is a ruptured pathogen. You see the morphology of these pathogens, and these pathogen you see, these are all ruptured pathogens. Ruptured pathogens means not active. So that we did. And similarly, like we did drug delivery system. And since there is lack of time, I'm not telling. So this is again, sir was Satyamurthy sir was telling like polymer synthesis. Okay, we have used completely renewable like polymer. And here for the first time in the literature, for the first time, okay, you just search anywhere in the literature, for first time in the literature, we made a linear polymer. That linear polymer used to make a cross linking to give you a cross-linked polymer. Such strategy never reported in the literature. This is the first. So one can make linear polymer with the help of light or heat. We can make a cross-linking. So this particular strategy has been developed, and like some company also has approached. So now we are working on this field. This also got like wide publicity. This is related to more molecular level tuning, because plant used to tune in a molecular level so that they can they can produce advanced smart material. That particular process has been like told. And here we use, you see, gluconolactone. This is carbohydrate moiety. And this one from castrol. castor oil. That is nothing but amanakku eണ്ണெய், you know, right? So we derived this from amanakku eண்ணெய் and coupled with this molecule got amphiphilic molecule, and these amphiphilic molecules can be used as a kind of a structuring agent for cosmetic and food application. You see, we didn't go deviate much. We used a renewable resource, and then that resource can that resource can be used for the development of new molecule. That molecule can be used for as a structuring agent for cosmetics and food products. So, and similarly we have did biofilm, anti-biofilm studies with this cardinal and then gluconolactone based molecule. This is again renewable resource based one. So you see the results all. So what I say is we don't need to see anything. Nature give enough information, or our ancestors already gave enough information. Maybe you talk with your grandfather or some grandmother, take the already like ancient technology and make new product and be an entrepreneur. And for making self-assembled molecules or structuring, for designing the molecule, there is no predefined protocol. And to get structural diversity, you can tune with the molecular level, so that you will get like lot of advanced materials which is stimuli responsive to temperature, pressure, concentration, pH, ion, solvents, because all these stimuli responsive structural changes were observed in nature. That's why I told you take nature as example. So some desired polymer with assembled structure also can be achieved by means of a simple protocol. So this is what the conclusion is. So I sincerely thank Vinayaka Mission Research Foundation for this opportunity to talk our research and then some of the basic topics. And I thank funding agency, DST, SERB, DST Inspire, DAE, BRNS for Young Scientist Research Award, and currently ongoing core research grant, DST, and currently an ongoing Spark project, that is international collaboration project. And I thank NIT Warangal for infrastructure and startup grant. And I thank INEAS, INSA for membership for the period of 2021 to 2025. Here I want to tell, INEAS is the only, there is no such young research association in India. So INEA is the first and one and only government approved, government recognized, government of India approved, recognized young association to just seed, to deliver scientific lectures, or to just what we say, to like take scientific temper to the society, especially to the remote areas. And I I take this opportunity. So if Vinayaka Mission Research Foundation is like organizing any scientific temper related outreach activity, no, so under INEAS may be supported. So I want to tell, we are INEAS member would be there, so that we all together can like do some scientific activity, scientific outreach activity, so that science can be like delivered throughout the country, so that everyone can feel, recognize, realize the essence of science. And our collaborators also, I thank my postdoc professor Jan for his constant encouragement, and Praveen Kumar Vimala, he is from NCBS, currently running 2 industry in India and 2 industry in one in UK and another one in US. And I thank Professor Dr. V. Sridharan, Central University of Jammu, C. Uma Maheshwari Shastra, and C.S. Srinandan, he is the one like doing biofilm or antimicrobial related activity. And Professor John Bosco Balaguru, he is the one doing electronic related one. And we did in vitro and in vitro analysis of our sample. We have some of the results not shown. Dr. B. Sarita was doing this particular thing. And I thank real heroes of my research like Dr. K. Lalita, Dr. Y. Sivaprasad, Muthuswamy Tamilangan, and current students Varaprasad, Arun, Tahira Banu, and all my MSc, MTech and BTech students, because you see these BTech students, MSc students, MTech students are real heroes of this research, because they are very much curious and they come up with a lot of ideas. So they are young mind. That's why now government of India also started this what we say, the scientific temper in the school level. They give like a lot of opportunities for the school students to develop product. Okay, this is our research group. Thank you very much. And any doubt there, you can ask me. and now not getting doubt, in future getting doubt also, please contact me either through phone or you can just drop a mail in my email ID. I'm very happy to answer. Thank you very much. Thank you for this opportunity.
Thank you, sir. Thank you for sharing your valuable insights with your presentation. And with that, the opening ceremony has come to an end, and it is time for the vote of thanks by Dr. S. Kavita, HOD of Computer Science and Applications SAS.
Good morning, all. I feel honored and privileged to propose a vote of thanks on this special day. First and foremost, I would like to thank our management for their seamless support to conduct this national conference. I thank our Director SAS, Dr. R. Shanmugavalli ma'am, for her constant effort, continuous support and guidance to make this conference as a successful one. We are very grateful to our Director Research, VMRF, Dr. SAB Satyamurthy sir, for accepting our invitation and gave his vital role from his busy schedule for gracing the inaugural function. I would like to acknowledge our gratitude to Dr. S. Nagarajan sir from NIT Warangal for sharing and exposing not only the technical knowledge as well as societal needs and issues and solution to the same in terms of green chemistry. Thank you, sir. I also extend my thanks to Dr. V. Anandan, HOD of Mathematics and coordinator of this conference. A well dedicated and his hard work make this conference as a result oriented. A special thanks to Maths, Chemistry, Physics and Computer Science HODs with their team of staff members as well as arts staff members for their work behind the scene. Our heartfelt thanks to enthusiastic participants who gave their paperwork and going to demonstrate it online in the next upcoming technical session. I would like to thank Samuel for his technical support and Sharon ma'am for conducting this inauguration session in a smooth and well-organized manner. Last but not the least, I thank our students, SAS students especially, for their active participation. Thank you all. Thank you once again. Thank you.
Kavita madam, the technical session starts at what time now? There is a break.
We can have a 5 minutes break, ma'am. Then first technical session will be by Department of Chemistry, ma'am.
Yeah, just pass around to invite all the presenters, paper presenters for the
okay,
session and with the timing. Okay.
Okay, ma'am. Okay. Thank you. Sharon, ma'am, you announced 5 minutes break and
We'll
at
start
at 10:50, ask chemistry participants to present their technical session.
If they
Some
have the
students
list
can
of
ask.
presenters, you can list the name list. You can read out name list of the paper presenters.
okay, ma'am. I have the list.
Yeah. You just read out their names. Okay.
Kavita ma'am.
Sir.
Students can ask the questions from the, to
okay.
They can listen.
Okay.
Dear participants, kindly take a 5 minutes break and we'll start our session, technical session at 10:50. And also the participants for the technical session, that is for chemistry department, is paper ID M17, that is synthesis, characterization and antioxidant studies of metal ion. And paper ID M41, that is differential aeration corrosion studies. And paper F43, absorption of malachite green dye form. Kindly be prepared with your PPT and share your screen when called for.
So dear participants, the paper ready M17 is synthesis, characterization, and antioxidant studies of metal ion acetylacetone complexes by Priyadashini and Manju Priya.
So the participant is ready. Shall we start, sir?
Okay, ma'am. Please activate their screen, ma'am.
Priyadashini ma'am, are you able to share your screen?
Yes, ma'am.
Okay, ma'am. Kindly share your screen.
Yeah, judges are there, Basha sir.
Ma'am, Nagaraj sir. I'll check with the Nagaraj sir.
Okay, okay. And somebody else also can join with him. My chemistry, somebody can join with him.
Nagaraj sir left out, sir.
So shall we call for 10-15 minutes for half an hour? Because we have a lesser
Class
participant.
irukama sir, ipo அவர் கிளம்பிட்டாருங்க.
Okay, then
all of us will.
among the chemistry department, you form a team and you judge the participants.
Ma'am, நீங்க இருக்கீங்கல்ல ma'am.
Yes, ma'am. You are the
நான்
chairperson.
இருக்கேன்.
அப்புறம் நீங்க தான் ma'am judge.
Because
Okay,
ma'am,
okay.
I'm going to present a paper. No,
You are from
Oh,
chemistry,
you are going
ma'am.
to present a paper. Okay.
Yes, of course.
Okay, then who is not presenting in chemistry?
Other than myself, only presenting the paper, ma'am. Others are not.
Okay,
Myself-
yes, sir. Then somebody, Surinder, you join with me to judge the candidates. Okay?
Okay.
Okay.
Kavita ma'am, shall we begin?
Yes, ma'am.
Priyadashini ma'am,
Ma'am,
kindly share your screen, ma'am.
ma'am, only the host can share with them.
Okay, 1 minute, ma'am. Try now, ma'am.
Yes, ma'am.
All the presenters, if for first 10 minutes, you will have to keep your video on. Okay? Sarun?
Yes,
Okay,
ma'am.
okay.
Yeah, just tell the presenters for 10 minutes, they will have to keep their video on. Okay?
Dear participants, while presenting your presentation, kindly turn on your video for the first 10 minutes.
Ma'am, shall we start?
Yeah, you can start.
Very good morning to all. I am Priyadashini from Rajeshwari Vedachalam Government Arts College, Chengalpattu. I am looking forward to talking about my topic, synthesis, characterization, and
Ma'am, Priyadashini ma'am, kindly unmute, ma'am.
antioxidant studies of metal ion acetylacetone complexes under supervision of my project supervisor, Dr. L. Kanniyappan. Let's start the
introduction.
Here we synthesize the metal ion acetylacetone complex. The here acetylacetone acts as a ligand, which is a anionic bidentate ligand that coordinates metal ions through two oxygen atoms, which is a odd base, and it prefers only odd acid cations. Especially divalent metal ions. Acetylacetone can be obtained by the reaction between acetyl chloride and acetone, which is a Feder-Crafts alkylation reaction. From that, acetylacetone can be prepared. Acetylacetone is an important intermediate for organic synthesis and also for some industrial purposes. It has two forms. One is keto and enol form. In the picture I show that keto and enol form. First one is the keto form, and next it will goes to the enol form, and from that the enol form, the OH, from the OH the H plus can be removed, so it becomes O minus, and on the other side also the double bond O becomes O minus. From that two oxygen atoms, it will act as a nucleophile, act as a ligand to coordinate with the metal ions. So only the enol form can form a stable chelate complex, not keto form. Only it's favorable in polar nature. Next, we go to the importance of acetyl acetone. Already we know that acetyl acetone acts as intermediate in organic synthesis and also for some industrial purposes like pharmaceutical, perfume, pesticides, and other industries. Only in the presence of enol form, acetyl acetone can form a stable chelate complex with copper, nickel, palladium, zinc, indium, tin, etc. Etc. It will also act as a metal cleaning agent and also a transistor metal chelator. It is used as an indicator for ion complex titration for the content of the content of ion and ion in colorimetric determination. Next, we go to the aims and objectives of my work. From my work, synthesis of nickel and cobalt acetyl complex. Cobalt acetyl acetate complex with high thermodynamic stability. From that, we perform the antioxidant study to how we use it as a chemotherapeutic agents. From there, we go to the material and the methods. Synthesis of transition metal acetyl acetate. Synthesis of transition metal acetyl acetate complex. First, we synthesize this acetyl acetate nickel 2 complex. How we synthesize is that 2 grams of nickel sulfate dissolved in 5 ml of DD water, and its pH will be at 3. And with the solution, 2 ml of acetyl acetone and sodium hydroxide solution also be added to adjust the pH. Only we have to adjust the pH. Sodium hydroxide is added. The pH will be at 8, and the mixture was constantly filled for 30 minutes using magnetic stirrer. We obtained the bright green color precipitate of this acetyl acetate nickel 2 complex, which is filtered and dried, which is used for characterization by using UV and FKIR spectroscopy. Next, we go to the cobalt. This cobalt acetyl acetate can also be prepared by the same method, but the pH will be at 12. Bright pink color precipitate is obtained, which is filtered and washed and dried at room temperature and characterized for UV and FKIR spectroscopy. Next, characterization by using UV visible spectrometry. UV visible spectra of transition metal complex only depends on the transition of unpaired electron. From acetyl acetone, we know that it has enol and keto form. From the enol form, the electron transition of electrons can take place. The C double bond O, the transition of electron takes place. The C double bond O. So only due to that, it has. Only due to that, it has UV visible spectro. The transition may occur between the split D levels of central atom, give rise to a DD or ligand field spectra. Due to the DD transition, the transition metals are colored. UV visible spectrum of nickel to acetyl acetate complex and cobalt acetyl acetate complex is studied by using the fresh paper solution of the complex using DMS and dissolved in DMSO as a solvent. It is only soluble in organic solvents, not soluble in water. UV visible of acetyl acetone showed a band at 250 nanometer due to the C double bond O N2 pi star transition of acetyl acetone, and this band shifted towards higher wavelength at 278 nanometer for nickel. After the complex formation with nickel and cobalt, the shift will be changes to 278 nanometer. So from that we confirm that acetyl acetone acts as a ligand in the metal ion complex, so that there is a bond between the metal and the oxygen. So, and it also discovers the covalent nature of the metal ligand bond. From that, nickel same will be observed at cobalt acetyl acetate complex, at 250 nanometer. From that we next we go into the FTIR spectros. Here the 270, the amp will be created at the 278 nanometer, which confirms the complexation between the nickel and the acetyl acetone complex, and also the here cobalt and cobalt and acetylacetone will be discovered. FTIR spectroscopy. FTIR spectroscopy can be recorded. FTIR spectroscopy can be recorded by Bruker FTIR tensor 27 spectrophotometer directly on small samples of the compounds in the range 200 to 4,000 centimeter inverse. The formation of complex between acetylacetone and metal ion confirmed by FTIR data. IR spectrum of acetylacetone shows stretching frequency of asymmetric carbonyl and symmetric carbonyl stretching vibration or 1714 centimeter inverse and 1598 centimeter inverse. After the complex formation with nickel, the shifts are observed at 1584 centimeter inverse and 1508 centimeter inverse respectively, which confirm the complexation between the nickel and the with the oxygen of the carbonyl group of acetylacetone. In cobalt acetylacetone complex, the shifts are observed at 1645 centimeter inverse and 1543 centimeter inverse respectively. Here, from that band, we discover the complexation between the cobalt and the acetylacetone complex. From that, another stretching frequency can be observed in nickel and cobalt due to the stretching vibration between metal and the oxygen group of oxygen of the carbonyl group of acetylacetone, which is at 552 centimeter inverse and cobalt 560 centimeter inverse, but which this band is absent in the uncomplexed acetylacetone, this confirming the participation of oxygen atom in coordination of the metal ion complex. The FTIR spectra 1714 which is to the carbonyl group of acetylacetone. Here the shift will be at 1584 in nickel complex and nickel complex, and in cobalt it will be at 1543 centimeter inverse, which confirms the complexation between the nickel and the oxygen of the acetylacetone complex. From the spectral data, we show that base acetylacetone nickel 2 complex show a smaller shift in the symmetric and asymmetric stretching vibration of carbonyl. This reveals that nickel 2 plus forms a square planar complex with acetylacetone, the coordination number 4. The structure of the base acetylacetone complex will be this. Next we go to cobalt. This acetylacetone cobalt 2 complex shows a larger shift compared to nickel. It shows a larger shift in the symmetric and asymmetric stretching vibration of carbonyl. It forms a octahedral complex with the acetylacetone, and the structure of the complex will be shown like this. Only the nickel and cobalt in its 2 plus state, a nickel 2 plus state forms a square planar complex due to the stable stellate formation, and the cobalt forms octahedral structure. Next we go into the antioxidant study. From the antioxidant, why we are using antioxidant is that free radical is easily formed in our human body. So this free radical can cause some type of tumors, cancer, etc. So for that we have to stop the growth of free radical. We are using antioxidant. So from we are using the complex, how we use it as an antioxidant. So from that we know that how antioxidant can be used. So antioxidant was measured in a reaction mixture containing 2 ml of sodium nitroprusside. So here we are using nitric oxide free radical scavenging assay. So nitric oxide can be prepared from sodium nitroprusside. So here 2 ml of sodium nitroprusside is treated with 0.5 ml of phosphate buffer saline, and varying volumes of metal ion acetylacetone complex are added, which is incubated at 15 minutes. After incubation, add 1 ml of sulfonic acid to complete diastazation. Then add 1 ml of naphthyl ethylene diamine. diimine dihydrochloride formed. The absorbance of which was read at 540 nanometer and compared with the standard natural antioxidant ascorbic acid. So here the antioxidant, the percentage of scavenging nitric oxide, which is equal to A0 minus A1 by A0 into 100. The A0 is the absorbance of the control, and A1 is the absorbance in the presence of sample of drug. From that, we conclude that nickel acesulfate, the concentration increases. And the concentration of the nickel acesulfate increases, the antioxidant percentage inhibition also increases. So from that, we know that nickel acts as an antioxidant agent, and also cobalt also in concentration increases, the antioxidant percentage inhibition also increases. So from that, concentration versus inhibition graphs are drawn. From that, we know antioxidant properties are concentration dependent. With increasing the concentration of the particular complex, the antioxidant property also increases. Here, the nickel complex has high percentage inhibition than cobalt, but both the complexes have good antioxidant property. Conclusion. The complex between nickel and the cobalt metal ion with acesulfate was synthesized, and this complex are investigated by using UV visible and FTIR spectroscopy. From the spectroscopy results show that acesulfate involve the coordination of the metal ions such as nickel and cobalt through the carbonyl oxygen atom of acesulfate to form a chelate complex of the molar ratio 1:2 with acetylacetone, and also cobalt form a chelate complex with 1:3 molar ratio. Here it is insoluble in water but soluble in organic solvent, so we are using a DMSO as a solvent. Stability of this complex is due to the formation of chelate structure. Next is go for the antioxidant study. From the antioxidant, how we can determine by using optical density measurement. The value observed are compared with standard natural antioxidant ascorbic acid. So the prepared bis acesulfate nickel 2 complex show a high percentage inhibition than the cobalt, but both the complexes have good antioxidant property. That's all. Thank you all. Thank you for the opportunity to talking about my topic with everyone.
Thank you, ma'am.
Yeah, this is Priyadarshini, is it?
Yes, ma'am.
Priyadarshini?
Ma'am?
Yeah. Tell me the application of your project, whatever you have done.
Ma'am, it is used for antioxidant.
Only it is used as an antioxidant, and any other else?
There are n number of natural products available as an antioxidant. Okay, you very well know about it. Why do you go for nickel and cobalt to find out other than they are chelating metals? And
Yes.
why do you go for antioxidant property in metals? What is the application of it?
So many metals can be discovered, ma'am. So that's why we're using cobalt and nickel for that, ma'am.
You mean to say many metals are used as
in acetylacetone acts as a ligand, ma'am. So it will react with many of the complexes.
No.
So we are using.
See, listen to my question. I'm not asking about your process, how it is acting as an antioxidant. There are many natural products available as an antioxidant, which are not 100% utilized. Then why do you go for nickel and cobalt as an antioxidant? Simply you are stating so many metals are studied for antioxidant capacity, so it has been studied. So if we are going to state that you have worked for knowing the characteristic as an antioxidant of nickel and cobalt, what is the application of it?
Comparing to other, நீங்க மத்த ligands மத்ததெல்லாம் கம்பேர் பண்ணும்போது இதுக்கு என்ன அப்ளிகேஷன்ஸ் வந்து பர்టిక్యులரா இருக்குதுங்கிறது மேடம் கேக்குறாங்க.
Okay, Priyadarshini, you think of this factor also because it is more many organic compounds, many natural products are available as antioxidant. When you are going to state that this is going to be an antioxidant, you will have to know really what advantages or what is the level of usage this metal can. Okay?
Okay.
Surender, you got a question?
Yeah, ma'am.
Yes.
If you have taken only UV and FPR, why you have not taken proton NMR? Then only you can conclude, right?
Yes, sir. Because of the cost we are using, we are not using for the NMR.
Because of the cost, see, then only we can conclude whether it will be present.
Priyadarshini, I have one question. Whether you are using nickel as a what electronic state it is, D8 or D7? Which state you are claiming?
D8, sir.
D8. You know that if you are claiming a higher oxidation state, your body may not perfectly suitable for taking as antioxidant. If the higher oxidation state goes higher, so your body won't be resistant for that. No, you take copper. If you're taking copper 1, it may be okay. It's maybe good for antioxidant. If you're taking copper 2, it may not be antioxidant.
Yes.
Okay. So you want to compare these things, surely you have to take EPR.
Through NMR only you can conclude.
Okay, sir.
Okay, many characterizations should be produced. Then only we can conclude the experiment. ஓகேவா நிறைய கேரக்டரைஸ் பண்ணீங்களா தான் இந்த காம்பவுண்ட்ல என்னென்ன டிராபேக்ஸ் இருக்கு அப்படிங்கறத நம்ம வந்து யூட்டிலைஸ் பண்ண முடியும். ஆல்சோ இந்த அசிட்டைல் அசிட்டோன் இஸ் யூஸ்ட் as a ஆன்டி கரோசிவ் ஏஜென்ட்ஸ். சரிங்களா? ஓகேப்பா, தேங்க்யூ ஃபார் யுவர் பிரசன்டேஷன்.
தேங்க்யூ சார்.
நெக்ஸ்ட் ஒன்
பேப்பர் ஐடி 41 சூர்யா மேம்.
Surya ma'am, are you there?
Okay.
Yeah. The screen is visible now.
Ma'am, you're not audible, ma'am. No, we are not able to hear you.
Good morning, ma'am. Is it audible?
Yeah, now it is. Yeah.
Good morning, ma'am. Good morning, everyone. I'm Surya Ranjus from St. Joseph's College of Engineering. I'm doing the project named Differential Aeration Corrosion Studies of AISI 410 stainless steel welded medium. So these are the contents. Now here AISI 410 and AISI 316 L stainless steels are welded using pulsed fiber laser arc welding procedure, and then we do the corrosion testing, and then we measure the amount of material lost by using weight loss method. So the test sample was prepared through by using fiber laser welding with a traverse speed of 417.79 mm per minute, and then it was exposed to 3 different medium, one normal hydrochloric acid, and then salt water for NaCl, and then NaOH, that is for base, and it was exposed for 48 hours, and then we measured the weight. We have come to a conclusion, which we'll see in the PPT later. So fiber lasers, these are very new technology. There are multiple types of welding processes, but why we have taken fiber laser? Because of its high precision, and then the amount of strength that it gives to the welded component. We have gone for this. Generally speaking, laser welding uses laser diodes and pumping mechanism they employ. This is the classification of welding. Fusion welding, we heat the two metals in contact, and then they melt, and then they join. But in solid state, there is no such heat application. We don't even give a heat that goes beyond the melting point of the metals. In our project area concentrates only on pulsed fiber laser arc welding, which is a hybrid combination of arc welding and then the latest type of welding, which is laser welding. Now, to talk about pulsed laser, these fiber lasers are a new technology that use solid state lasers. Now they use a very low amount of rare earth element in the lasing medium, and then they get photons are emitted to generate lasers, and that is called as pumping. Ytterbium is generally used as a doping element, and here in our in my project also we are using Nd:YAG lasers. These are having high power and high accuracy in focusing. This is the welding setup that I used for my project, and here you can see it is a robotic arm set. It has a robotic arm also. Then it has got arc torch as well as a laser welding system. It's all computerized. Then it's not manually done. Now corrosion. The second part of the project is about corrosion. So corrosion is nothing but, as we all know, it is a deterioration of the material when it is exposed to some corrosive environment. So every metal has got a natural tendency to get corroded, and then it will.
Excuse me, Surya, can you go to the previous slide?
Yes, ma'am.
Yeah, just explain this. You have a pointer?
No, ma'am.
Yeah, you explain this part.
So, ma'am, this is the laser setup that I got to use for my project, and this is the so this is the place where we keep the two materials to be welded, which is AISI 410 and 316, and then there is an arc torch to this is a laser, and then you have an arc torch which will simultaneously do the welding purpose. That is, it will melt the metal, and then it will join both of them to give a better welded area. So yeah, then yes, ma'am. So the frequency that we used were of three things, that is 4,500 hertz, 4,000, and then 5,000. 4,000, 4,500, and 5,000 hertz. Similarly, we used three different power, and then three different welding speed also. So yeah.
Okay. Proceed.
Okay, ma'am. So corrosion, and then importance of corrosion studies. Mainly, there are two main important things, because first one, according to Economic Times, India has to spend nearly $100 billion for corrosion annually, and that is a very huge amount. So we have to cope up with that, and that's one of the major important features. Second one, our natural limit. Resources are very limited, so we won't get the supply for ever for the whole lifetime of Earth. So we have to utilize it efficiently. That's why we have to do this corrosion study. Conditions necessary for corrosion. There are more. There are four conditions. First one is there should be an anode, because what we're going to see is an electrochemical corrosion in my project works. For that, there are four conditions necessary: an anode, a cathode, then a conductive path, a liquid path, generally an electrolyte, and then there should be a conductor, like the weld joint or some rivet, and then bolted joints. Now, absence of any one of them can limit the corrosion. Then types of corrosion, generally say 8 types are there: uniform, galvanic, crevice, pitting, intergranular, selective, erosion cracking, and stress corrosion cracking. Galvanic, there should be an anode and cathode, so electrons move from anode to cathode, thereby forming rust and then a pit. Then stress cracking corrosion means initially there is a small amount of corrosion, means then later stress will add on to it, and then more amount of corrosion will happen. General corrosion, anywhere at any at some same rate on the whole surface it can occur. Localized means only on some area of a material so that corrosion will happen due to exposure to some caustic agent or some to some corrosive ingredient. Then caustic agent means due to the exposure to some caustic agent like NaOH or acid or something like that, this corrosion will happen. Then differential erosion corrosion. So this is nothing but we have a material, and then when the material is exposed to two different concentrations of oxygen, there this kind of corrosion will happen. That is, for example, for our welded region, first it will have a smaller anode and then a larger cathode. Means from anode to cathode, the electrons will traverse, and then corrosion will happen. So that is what is called as differential aeration corrosion. Example is crevice corrosion. Pitting corrosion is also an example of a differential. This is an image. It will generally happen in gutter pipes, water pipes, then such storage things. Now, as a part of my initial phase of my project, I wanted to know what are the different types of steels that are generally researched on. So I found out that there are three types, like ferritic, stainless, and bayonet, based on the composition, mechanical composition, apart from the general types like tool and alloy and all that. So in this stainless steel itself, 316 alloy, 316 and 410 are very much less explored when it comes to the welding and all that. Those studies are very limited, so that's why I have taken this paper. Then selection of material. These are the two materials. These are the two materials that I had taken. So the alloy 410 will be is having a 12% of chromium, and then this is a composition of the. Now this is a mechanical property. It has for a temperature range of 204 to 650, it shows a tensile strength of 1475 to 300. Here I have considered only tensile strength for my project. That is, I found out only that mechanical property. Then 316. This is the composition. Then mechanical property. It is 485. Then application 410, generally it is used for pipelines, valves, nozzles, dental and surgical applications. Then 316 means heat exchangers. And again, the same applications, it goes hand in hand. Now this is the material that I bought, 410 and then 316L. Need of the project. As I said, it is very much less explored area, and also to put in more light, so that the people who are coming behind me can obviously have a reference for knowing how this welded joint behaves in three different medium, like acid, base, and salt, and then the differential aeration corrosion also. So the objective to obtain a welded joint, then to determine the mechanical behavior, and then to learn about its corrosion effect, and then to analyze the surface morphology, and to learn about a synthetic inhibitor to synthesize one. Now methodology. This is a methodology. First, it starts with the introduction, and then literature review, material selection. Then we do a design metrics by Taguchi, orthogonal L9 method. Then 9 samples experiment. Then mechanical behavior. In between, we do the corrosion study, then results and discussion, and then the conclusion. So literature review, I have taken 10 papers. So these are the 10 papers that I took. For my thing. This is the welding setup again. Now input parameters. These are the 3 main input parameters that are considered: frequency, power, and speed. Now Taguchi L9, 3 parameter orthogonal array, because I wanted to reduce the number of experiments that I had to do. Thereby can save time as well as money also. So these are the this is the L9 orthogonal array, and then further. Now tensile test. So tensile test was done using an ultimate tensile testing machine. The shape according to ASTM E370 vision setup, we cut it in the shape, and then this is the image of it after breaking, and then we observed this thing for each sample. The tensile strength was recorded as these. So in this, if we see the maximum tensile strength was observed to be that of to be that for 6, sample number 6, because the traverse speed is very less, and then the power is higher, and the frequency is medium. When the traverse speed is low, the welded area will be much stronger. So that is that can be one of the reasons why the tensile strength was recorded to be very high. But whereas for 7th sample, the tensile strength is the minimum, because its frequency is too high, and probably because of that reason, and the power is very low. Because of these two reasons, the tensile strength could have become lesser. Now, corrosion studies. In differential aeration corrosion test, we kept AISI 410 on the top, and then 316L in the bottom. So 316L showed much more corrosion rate and compared to that of AISI 410. So the top AISI 410 is having less corrosion, more corrosion resistivity, and compared to 316L. So the medium preparation, we took 3 medium: acid, base, and salt. So for acid, we mixed hydrochloride in water. To get 1 normal of HCl, we have to mix 8.33 grams of HCl in water. Water in 1 liter of water, in 100 ml of water. So the properties I have mentioned here. Similarly, 1 normal water. Then NaCl also was prepared in the similar way, like 58.44 grams was dissolved in 1 liter of water, and then we got 1 NaCl. The corrosion test, what we did was we welded the samples, and after that we washed it with water. Then we dried it for 80 degrees Celsius, okay, for 1 hour. And then after drying, the samples were weighed, okay, and then they were immersed in 1 normal artificial seawater using some impure salt crystals. And after that, this HCl and the other 2 medium were prepared, and then 9 more samples were put in these 2 medium in the second time. Now so what happened was, the weight, how much weight lost, and all we'll be seeing in the later slide. So the procedure we considered is a weight loss method. There are 3 methods to measure corrosion. First one is polarization, Tafel polarization method. Second one is electrochemical impedance spectroscopy, and third one is weight loss method. Out of these 3, weight loss method is much simpler and easier to calculate and proceed with. So I chose this method. There is a formula for calculating weight loss, that is the corrosion rate, 87.W by D80, where W means weight lost, D means density of the steel, A means surface area, T means exposure, time of exposure. So how it works means, we expose this into the, suppose we take 1 sample, we expose it into HCl, means for 48 hours that is the exposure time. For 48 hours we immerse it inside this HCl. After that we take it out, we dry them, and then you measure for the final weight. So that initial weight minus final weight will give you the amount of weight it lost. So applying that in this, you'll get the corrosion rate. Now corrosion testing, these are the the medium that we took. Corrosion test before drying, after immersing, and then before drying. This is the image. And then differential aeration corrosion in basic, medium, salt, and then acid medium. Initial weight of the sample 9.304, and then weight lost after corrosion, it is this one. So this is how we measured. Now corrosion testing in salt solution. If we see the initial weight in salt for these 9 samples are recorded here, but the final weight are given here. So initial weight 9.51 means final weight is 9.48. So the weight lost was 0.026. For the pH of 7.7, that is in salt, for among all the samples, the maximum amount of weight was lost by sample number 1, whereas the least amount of weight lost by was by sample number 2. So that states that there is more corrosion for sample 1, and there is no corrosion for sample number 2. Now this is the inference that we got. For acid solution.
Excuse me. Surendra sir, are you looking for the timing? Hello?
Yeah.
Surendra? Yeah, you're
Beyond
looking for the time.
Yeah, beyond time is going on.
Okay, proceed.
Yeah.
Okay, ma'am. It's almost it all. So for acid, this is what we observed. So before weight and after weight, the maximum weight lost was for sample number 5. For sample number 5, and minimum was for sample number 2. Then similarly for in days, the maximum weight was lost by sample number 7, and the minimum by 1, 4, 5. Multiple samples had minimum weight loss reported. So this is what this is my entire experiment. Now for results and discussion, we can observe that when you keep 3 for differential aeration, when you keep 316 in the bottom, it will corrode. It will have much corrode. It will corrode much higher than the 410 steel. So you should, for mechanical purposes or in when you go for the application oriented thing, you should keep the 410 steel in contact with the medium, the acidic or base or salt or whatever it is, the medium. The 316 should be kept on the other side. That's how it has to be kept. And in the conclusion, so yes, so conclusion, we can say that the amount of the tensile strength, it has got direct connection with the speed. When speed increases, the tensile strength will correspondingly be lower. So and yes, ma'am. From all these corrosion tests, we found out that which all samples are having greater corrosion rate, and then the one with what are having lesser ones. Acknowledgement, I should sincerely thank Dr. R. Jayaprakash sir from AVIT campus for supporting me in this entire work. And then these are the references, and thank you.
Yeah, just tell me, you have done a corrosion study, is it not?
Yes,
you have done a corrosion study with the different salt, acid and other things. What is the first part which you were explaining about laser arc?
Ma'am, actually we are not, we are, first part is welding. We take two stainless steels, ASI 410 316, we weld it using this fiber laser arc welding thing. Then that to test the corrosion rate of that particular weld, we use these 3 medium. We expose it to these 3 medium.
So, okay. So did you compare that with the normal welding process which is happening?
No, ma'am, like that I didn't.
Then how will you conclude your report? If you want to show that your laser arc welding is efficient and you want to show the efficacy of the corrosion rate with the different salt, acid and other things, you will have to compare with the normal welding process, is it not?
Yes, ma'am.
You have to put the table like this is the normal welding table, this is the pulsar electro welding table. So what is the corrosion rate, which is good, which is poor? So you have to compare, right?
Yes,
then only you can conclude.
Okay, sir. I'll do that, sir.
Ma'am, another question, ma'am.
Yeah, like really, how far this laser welding is advanced? Nowadays, I feel it is all laser welding is happening even in normal welding, whatever we see in the roadsides. Is it not? Nobody is going for the welding process, that solid state welding or all that is not happening nowadays.
Yes, ma'am. Actually, we are using.
I want to know what is the advancement which you want to show through this project?
Ma'am, actually, we are just, it's a trial, like how these 2 materials have never been welded by any.
Okay. See, you have done this project for your ME research, is it not?
Yes, ma'am. Yes.
Yeah, you always, when you are, it is PG, it is UG, it's okay that to know the knowledge about welding process or laser efficacy, you can do it. But when you are going for a PG project, you will have to really look towards the technology application, and some advancement in the project should be looked for. Okay, see to that, Surya.
Thank you, ma'am. Sure, ma'am. Sure.
Surya ma'am, I have few questions. You have taken only 410 and 316 alloy, right?
Yes, sir.
Yeah, these are all very high cost effective material comparing to 302, 302 low nickel stainless steel. Then why did you choose this? It is a high cost effective material, 316, right?
Yes, sir, it's a bit costly.
Then why did you choose?
First I thought, sir, I'll do in bayonet, but then bayonet is very expensive and it's difficult to do in that. That's why I chose, okay, let me do with 316L. So cost, I didn't consider at that point of time. So
cost, we are doing the research for public, right? Then
yes,
cost is the biggest role.
Yes.
Okay, okay. And next one, you have already said the weight loss and electrochemical spectroscopy, like electrochemical impedance spectroscopy, TAFL polarization studies. You have chosen only weight loss method, but you should choose electrochemical studies like potentiodynamic polarization, electrochemical impedance spectroscopy. Through that only you can calculate exact corrosion rate, right?
Yes, yes, those calculations will give very accurate data.
Yes. Then why did you choose weight loss? Already you have said it is the simplest method. Then why we need to go for simplest method?
Sir, I'll try to include this one.
In
also.
future you can calculate. Okay. Okay, pa. Thank you. Thank you for your presentation.
Thank you.
Next one, Basa sir.
Yes.
Okay, sir. You can start. Right.
Shall I share the screen?
Yeah, sir. No, share agla, sir. Hello.
Sharing, sir.
Yeah. Now it will be visible. Okay. Thank you.
Good morning to one and all. Thank you very much for giving this opportunity. My topic is adsorption of malachite green dye from aqueous solution using activated carbon produced from Dataros ammonium leaf. So we know very well the adsorption process is very, very old one. Even though it's very old process, nowadays this is highly useful in the process of removal of dyes, elements, other things. This is highly useful for pollution abatements. So even though we have a advanced technique, nowadays still we are not able to clean the environment. So still we have a lot of pollution, lot of pollutants are there. So nowadays we are using the activated carbon to filter off the industrial effluents, or we are treating for water effluents, water wastewater. So among them, the adsorption is a very efficient one. In the adsorption process, nowadays we are using the activated carbon produced from the coconut shell. The cost of the activated carbon is very high, nearly per kilogram 3,000 rupees to 4,000 rupees. So now we are looking after the next low cost adsorbent. First of all, I'd like to tell about what is adsorption. Adsorption is a surface phenomena. In that we are using the two things. One is adsorbent and adsorbate. Adsorbent is the material which is used to adsorb attract the metal or any dyes or any organic pollutant. The organic pollutant, the dyes or any metals are called as adsorbate. So this is a small introduction about this one. First of all, this is my table of content. First, I'm going to give the introduce, need for study, review of literature, objective, materials and methods, result and discussion, conclusion, and finally we have reference. So what is the introduction about this paper is? So we know the organic pollutants originate from domestic sewage, urban runoff, industrial effluents, and agricultural wastewater, sewage water. All these things we are getting a lot of organic pollutants which will pollute the atmosphere. So as I told that even though we have a advanced technology to filter off many pollutants, still we have the pollution rate is keep on increasing. The pollution abatement is not yet finalized, not yet achieved. So now that's why we are going for a low cost absorbent. As we have a lot of pollutants in the water, the oxygen depletion, the oxygen will not go into the water, which will affect the severe consequences for the aquatic animals like fishes. And also the wastewater contains large quantities of suspended organic pollutants, which reduces the sunlight in the water. So in the water, inside the water, we have a lot of water plants that also affect the photosynthesis of the water plants. So organic pollutants means which includes the pesticides, fertilizer, hydrocarbons, phenols, plasticizers, biphenyls, detergents, oils, greases, etc., including the dyes. So toxic organic pollutants like dyes trigger the numerous environmental problem, because nowadays we are not only nowadays, for the past 150 years we have been using the large amount of dyes. No other way, because no other way we should use the dyes, isn't it? Because without dyes, because we are wearing different colors of shirts and saris, and even though not only for wearing purpose, but also to differentiate in the industrial. So red color we have differential danger one, like this one. We are using the paints and the dyes are using in the numerous way. So even though we have natural dyes will not stick well into the fabrics. So that's why we are going for the chemical dyes. Chemical dyes have a numerous, is like even this is a toxic substance. So even though we are using 100% of dye, the 100% of dye will not be utilized for the dyeing purpose. Only the 50 to 60% will be stick on the fabrics. The remaining 40 to 50% will go into the go as a pollutant into the land or the river, or which is the land pollution, water pollution. So this will keep on bioaccumulate. Bioaccumulation means the dyes and organic pollutants keep on accumulating into the plants while eating that plants by the human beings or animals. So that will accumulate in our body. So that leads to diseases. So that is called the bioaccumulation and biomagnification. So this can be removed very in the very cheapest way by using the adsorption process. So by using the adsorption with the agricultural wastes or plant material. Okay. So we're not going to synthesize a new one. Whatever waste available, we can burn it, we can convert it as a carbon, then we can use as a adsorbent. Okay. So by using this adsorbent, we can remove the pollutants like dyes like malachite green, Congo red, magenta dyes. Many dyes can be removed by using the adsorption process. So today I choose, and in this paper I have chosen the removal of malachite green using the Dactylosmodium leaf. So the Dactylosmodium is a plant it's called as thorn apple plant. So what is the need for study is this? So we know very well the industrialization and urbanization, because of this one, a lot of pollutants will be mixed with the land or water. We need we're not in the position to maintain the sustainable development. The sustainable development means we should not we should leave the resources for the future generation. That is called as sustainable development, and also we should save the future environment for the future generation. And also we are wasting a lot of agriculture plants or any materials that can be utilized as a adsorbent to do the pollution abatement. So here we have a lot of techniques are there for filter of the effluents like coagulation, filtration with coagulation, precipitation, ozonation, adsorption, ion exchange, reverse osmosis, and advanced oxidation process. Among them, I have chosen the adsorption process because of the low cost. We no need to spend much more money for this one. So if we have a plant material, any waste material, we can burn it, we can convert as a carbon. Then we can utilize as a adsorbent, we can filter off the effluent. It's a very, very cheapest material. Okay. So, but in the other techniques, we have to spend some more, it's non-economic compared to the adsorption. So, so we should find out the most capable and fixer method. And also, now, as I told that the cost of the commercial activated carbon is very high, nearly 3,000 to 4,000 rupees per kilogram. We should find out the low cost adsorbent. This is a need for study. So that's why I chosen the adsorption process. Adsorption has many rewards such as a low cost, we can prepare the low cost adsorbent, effortless accessibility of the adsorbent. We don't need to spend much effort. Spending of domestic, we can use many wastes like domestic, biological, industrial wastes as adsorbents. We need only the little operation cost and trouble-free operation. Anyone can operate, anyone can filter off the effluents, and also we can regain the adsorbent after regeneration by doing the desorption process. And also we can regenerate the adsorbent as well as adsorbate. So even if you filter off the dyes can be regained by doing the desorption process. Okay. So last one is the ability of removing the dyes over a broad series of pH. We can utilize a different pH. The pH condition, we can remove the adsorption. Also, this adsorption is environmental friendly. That will not affect the environment and easily available. So literature review to find the low cost adsorbent. I found out the agriculture wastes, byproducts, industrial solid wastes. Now I just display some of the adsorbent, water hyacinth roots, niguri leaf. A lot of researchers have been done in this area. Even though we have done a lot of researchers, but still we have a lot of pollution. So objective of this my topic is to study the elimination of the removal of the malachite green dye from the waste material, wastewater, so not waste material, wastewater by adsorption method by using the batch process, and also to investigate the adsorption behavior of adsorbent, to study the influence of by using the various pH, what is the nature of the adsorption, by using the different concentration of the adsorbent dose, what is the effect of initial concentration of the adsorbent, and at a different temperature, what is the adsorption level. All these things have been investigated. And also for analysis, I've done the UV spectrophotometry and then the SEM scanning electron microscope to analyze the surface area of adsorbent before and after the adsorption. The third one is I analyze with the FTIR spectrophotometer to find out the functional grooves present in the surface of the synthesized carbon material. And also I've done the bed analysis, the Brunner Emmett Teller analysis to find out the surface area. And finally I've done the XRD also. XRD in one of the primary technique used by chemists to examine the what are the group, what are the group, not group, what are the element present in the material. So my materials and methods, as I told this, I chosen the thorn apple leaf. The biological name is Datura ammonium. In Tamil we can call it as mullu kai solluvaanga. So we can call it as thorn apple leaf. I chose only the thorn apple leaf alone. Okay, so I collected that one, dried the leaves, and I convert as a carbon by using the muffle furnace, ground well. By using the meshes, we got the different size. I got the homogeneous powder with the micron size of 9.6 to 41.5 micron. Even if you ground well, if you get the nano size level, so the surface area will be very bigger. So as I done up to the micron level, why didn't you go for the nano size level is because nanometer level is because I should grind by using the ball mill. The cost was somewhat high, 600 rupees per grinding. So as we're discussing about the low cost adsorbent, so I stop up to this by using the mortar only. I done this work. I achieved up to 9.6 to 41.5 micron. So preparation of adsorbent, I have chosen malachite green as an adsorbent, as a pollutant. I have purchased as a chemical as an analog grade. So as it is a grade analog grade, which is not which is utilized without further purification. So I've done the batch absorption. The batch absorption can be done with the help of the UV spectrophotometry. The malachite green has a lambda max of 500 nanometer. Then we analyze all these things by using the UV spectrophotometer. From this, we obtain the results which will correlate with the compare with the typical Freundlich and Langmuir adsorption isotherm. So these are very well-known world one adsorption. Still, we are using these two adsorption isotherm for the verification of the adsorption process. So adsorption isotherm data were fitted to the isotherm equation. And also we have done the characterization studies by using the same BET method, Teller method, and FTA and XRD method. So result and discussion, effect of pH on removal of dye. So first, as I chosen only one dye, and my adsorbent is datarosomodium leaf carbon DSLC. In future, I'm using the DSLC in the short form for the datarosomodium leaf carbon. So here I've done the adsorption with a different pH from pH 3.8 to 7.4. Which shows that at a very low pH, it shows very high adsorption. It shows, see, when we're seeing the graph, at a low pH means when it is in acidic condition, it shows a very high adsorption. Where if you keep on increasing the pH, the adsorption is keep on decreasing. At a particular pH, it attains constant rate. So what we conclude is that the low pH is effective, is highly effective. So effect of temperature on removal of dyes. Temperature. If you increase the temperature of the we know very well temperature will increase the pore size. As increase the pore size, more adsorption takes place. This is a basic one. Here I increase the temperature from 308 Kelvin to 318 Kelvin, that is 25 degrees Celsius to 35 degrees Celsius. I achieved the 62.7% to 83.8%. So effect of temperature. See, at the low temperature, the adsorption is gradually increasing at a particular temperature. It attained a constant rate because while increasing the temperature, the pore size will be increased. The size will be increased. The pore size will be increased. So after accumulation of the adsorbent, that will be fulfilled. Then we attain the constant absorption. So effect of adsorbent dose on removal of dyes. As you know, if we have low adsorbent dose, if we have low amount of carbon, so we have low surface area. Therefore, the amount of adsorption is little. If we keep on increasing the adsorbent dose, that is the carbon dose, then what will happen? Then we get more surface area, so more adsorption takes place. So that also proved by using the UV spectrophotometer. If you increase the adsorbent dose, the adsorption is keep on increasing. That also achieve at a particular state, that in this constant steady state, because all the holes, all the pores will be occupied by the adsorbent. So I increase from 0.5 to 0.8 gram. That also shows a very good result. On increasing the adsorbent dose, the adsorption is keep on increasing. Effect of initial, next one is the effect of initial concentration of the adsorbent. Of course, as we have at the initial concentration, we have more sites of pores, because in the initial concentration, there is no occupation of any adsorbate, there is no occupation of any dye. Therefore, we have a fresh surface area. So as we have in the initial concentration, as we have fresh surface area, so we have more surface area, therefore the concentration, so the adsorption is very high. As the adsorption is continuing, the surface area will keep on decreasing. That also, after completing the adsorption, that also attain the constant rate. Okay. Next is adsorption isotherm. By using the UV photometric results, that will fit into the keep it in the two isotherm, the well-known isotherm called as Freundlich adsorption isotherm and Langmuir adsorption isotherm. So it shows from this I got the R square value, regression coefficient, the coefficient of the other is called as coefficient of adsorption. The maximum value is 1, merely 1. I got one is 0.9702, which also shows indicate that is very good adsorption took place. So this graph is there. I didn't draw the graph because I had a lot of slides are there. I have more than 60 slides. I reduced at 30 to 35. Just given the result alone. In the Langmuir adsorption also, I got the R square value nearly 1. So we had two correlation coefficient, the positive correlation coefficient and negative correlation coefficient. Positive correlation coefficient will be utilized for the adsorption, adsorption and a negative correlation coefficient for desorption. The negative correlation coefficient will be less than 1. The positive correlation coefficient is more than 1. So here we are, as we concentrating only on the adsorption, then I use only the positive correlation coefficient, that is R square value is 0.93. So 93, that is nearly 1 value. So, and also I've done the SEM analysis. SEM analysis is highly useful to find out the surface, active sites, how many holes, how many pores are there. So that can be indicated with the help of scanning electron microscopic images before adsorption and after adsorption. The SEM images shows the holes, a lot of pore structure of the DSLC. DSLC stands for dactylose ammonium leaf carbon. So which contain full of voids, and voids means porous structure. So the adsorption shows a well pore structure indicating good possibility of dyes to be absorbed. So next one is, this is before adsorption. Next one is after adsorption. After adsorption, this is magnified one. After adsorption, in the pores, a lot of dyes are occupied in the dye. The malachite green is absorbed by the DSLC. So this is after adsorption. The pores are covered with the dyes, which shows the adsorption capability of the adsorbent. So that will remove the dyes from the effluents or the aqueous solution. And also done the analysis, IR analysis for the group, find out the groups, the before and after adsorption. First I done with the DSLC, only with the carbon and the adsorbent. I got this result, IR result, which this shows the different frequencies per that is in terms of per centimeter, which will indicate the we know very well, not very well, the IR spectroscopy is a fingerprint for the groups. We have by comparing the standard values, the 3326 indicate the stretching mode of the OH group, 1632 for the CO stretching. Like this, we have analyzed this one. We conclude that these groups are present in the DSLC. Also, this is done after the adsorption. Adsorption also indicate that there is some small shifting is there. So which indicate the malachite green is absorbed by the DSLC, DSLC, that ammonium leaf carbon. So here also indicate the different structures which indicate. I indicate as a talc. Talc is thorn apple leaf carbon. We can call it as talc acid or DSLC. I've done the XRD analysis also. From the XRD analysis, which the non-existence of the sharp peak. The sharp peak is non-existence, which indicate that this is amorphous structure. Amorphous structure of the.
Basa sir, time up sir.
Okay, sir. 2 minutes, sir. So which shows the amorphous structure of the adsorbent. So analyze analyze many physical properties like surface area, pore volume, pore size, the ash content, moisture, etc. Of the DSLC. So conclusion, in this study, the adsorption of malachite green dye and adsorbent prepared by the DSLC, that is dactylose ammonium leaf, as below. It shows 52.6 milligram per gram of the adsorbent. The elimination of malachite green can be done as it is, right? Like 52.6 milligram per gram. Actually, when compared to the commercially activated carbon, it is 70 to 80 milligram per gram. But the cost is, when comparing the cost, it is very low cost when compared to the commercially available activated carbon. As I mentioned, this one, it is very important to note that the expenditure carbon prepared from the dactylose ammonium leaf carbon is much lesser than that of the commercially available activated carbon. As we are concentrating only the low cost adsorbent, we can achieve this one, even though the adsorption capacity is lesser than that of the commercially activated carbon. These are my list of references. That's all. Thank you.
Sir. Ma'am, question.
Yeah, Basha sir, I have too many questions for you because as you have stated already, this is an old methodology and this is an old thoroughly studied process.
Yes, of course.
And I have many questions. I don't want to embarrass you. One question is, like you are saying, you have selected this thorn apple leaf.
Yes, ma'am. Yes, ma'am.
Okay. Is it a waste material available on the land or it is any beneficial material?
Thorn apple is a waste material and it's not useful for as a consuming purpose.
Okay.
That's it, ma'am. It's like a bushes. You can
It
utilize
is widely
widely
available.
is yes, ma'am. Widely available, ma'am. It's abundant. It's abundant, ma'am. It's abundant, ma'am.
Abundant in area. In which area?
In all over the area, ma'am. In Tamil Nadu, it's mostly abundant area.
One thing is when we select the adsorbent, we will have to see to that it is a waste material. It should be
yes,
waste.
yes, ma'am.
It is a low cost. It is a waste material widely available. When you have presented a slide talking about this water hygiene, and there is another one called Congress grass or Parthenium.
Yes,
these are all the everywhere, all over the
Yes,
nation, it is available.
Yes, ma'am.
I don't think Thorn apple is widely available like water hyacinth or like a Parthenium. Okay, that is one thing of it.
Yes, ma'am.
Next is where are the industries or where are the places where this adsorbent are used for wastewater removal?
Most of the dyeing industry, they're using the activated carbon, ma'am.
Have you seen it? Have you seen it?
No, I've gone through the research
Only
papers,
literature.
ma'am.
Only
Yes.
literature. Definitely speaking, they are not using it. If at all it is there, where the widely studied chief material would have been replaced that. Whereas in few of the foreign nations, they are using for the domestic wastewaters are being sent through the pipelines of this adsorbent. Okay, that is one thing for your thing. I want to know. You will have to study that. Another thing is. Have you tested with the real wastewater, or you have prepared this dye and you have used
yes,
it?
Yes. For this paper, I just prepared the dye solution, ma'am. I didn't analyze with
you are doing it for your PhD, sir. It should not be like any of the PG thesis or MPhil thesis where you prepare a synthetic solution, you test your
no, ma'am. For PhD, I have prepared, I analyzed with the effluent also. But for this paper only, I analyzed only with the only one malachite green dye.
Maybe if you are considering this for your PhD as a national paper presentation, then you will have to test your solution with the wastewater.
Okay, yes, ma'am. Of course, I will do, ma'am. I'll do as a future studies.
Again, another thing, the same type of work what I have done some 20 years or
yes, of course,
more than 15 years before, you are repeating now because all researchers have left out this because of so many questions raised by the doctoral committee because the waste, what you are going to load, and after that, how you are going to dissolve, and after desorption, where you are going to do. And again, in our process itself, you are going to modify the pH of the solution, what you are preparing, which is against the nature. You are saying the low pH level will increase the level of absorption.
Yes.
Not okay, so that is not acceptable because the level of pH which we are going to leave out after absorption is going to really, we cannot say it is a pollution effective or pollution free. So have all this in your mind. I don't want to embrace here. Get prepared for your viva when they ask this type of questions.
Okay,
sir. Okay.
Thank you, ma'am.
Okay, sir. Okay, sir. Thank you, sir. Thank you so much. Basa, sir.
Okay, sir. Thank you, sir.
Dear participant, is there anyone who wants to present right now? The session is about to get wrapped up.
Sharon, ma'am.
Yes, sir.
Afternoon computer science.
Yes, sir. Yes, sir. So shall we 1 o'clock, ma'am. 1 p.m.
So now there are no
Lunch.
presenters, only 3 papers in chemistry.
Yes, ma'am. Yes, ma'am.
We have only 9 papers.
Anybody presenters are there? How many papers in chemistry, Surinder?
Around 10, ma'am.
Then why they haven't come forward?
Don't know.
It has got a price value. So if the,
Yes, ma'am. Yeah, ma'am.
you're not going to present, then you will not be considered, no?
Yes, ma'am. Yes.
So shall we wind up this session, then start
Yes,
the
ma'am.
session by 1 o'clock?
Next session. Yeah, ma'am. Yeah, ma'am.
Sangamit madam is willing to present paper, but she is busy with that. The NIT meeting is going on.
மார்னிங் 10 o'clock ஸ்டார்ட் பண்ணலான்ற ஐடியாவில் இருக்கோம். நீங்க 10:30 கொடுத்துட்டுங்களா?
Okay, sir. Okay, then we'll meet at again at 1 o'clock.
1 p.m. Yeah.
Dear participants, the technical session for the chemistry has winded up, and we'll meet up at the computer science technical session at 1 p.m. today. Thank you all for joining us today.
Thank you.